welcome, and we will begin with a discussion of verticals, starting with Mr. Kirongbi. Thank you.
Thank you, David. Hello, everyone. Today, by the way, I want to, first of all, on behalf of the NJ, I want to welcome everyone, especially from Korea City Forum, to the fourth session today. Today, I'm going to talk about North American view, especially about the 60 verticals, with some translation then into use case and recommendation. So we have, as you already know, of Connectivity Alliance, we have 6 working groups, and out of that we have National 60 Roadmap work group led by Anitaba and Mark Grant. And the application working group is trying to transform, translate some vision or roadmap aspect into certain type of use cases, especially for generating recommendations and potential requirements. So that's something I want to talk about today, with emphasis on the North American perspective. So we have 6 audacious. You see my point. So in the picture in the left, you can see the 6 audacious goals launched by Connectivity Alliance, I think 2 years ago. And the thing we are working on, we have been working on in application working group and other working group is about how we transform those vision into reality, including use case identification, which is going to be influential to the North American market, not only for the North American market, but also for globally in the context, in lines with harmonized, unified global standardization for 60 era. So we have identified 4 foundational areas of use cases. That is everyday living. So how we can help to improve the quality of everyday living, daily settings, and also how we can help provide truly immersive experience in the context of enhancing the quality of education, entertainment, gaming, things like that. And also more important, not the least, but more important aspect in the context of societal goal may include critical goals and high-level societal goals. So they are going to be, very important aspect, not only for the engineering aspect, but also for whole increased level of the future community. So this is the brief thing that I want to share today. This one is the NJ's vertical industry white paper published last year that has 8 verticals: agriculture, automotive, which is quite important, also aligned with United Nations Sustainable Development Goal, and also EGE, education, gaming, and entertainment is one of the important aspects, and e-health. So that's also aligned with the global trend of population aging. So we need to provide a certain type of support that can increase the labor intensity or dimension to support the aging population in the global society. So that's first 4 vertical industry aspects, and industrial IoT, and many things, industrial automation, and mining is one of the important aspects from the North American perspective. And public safety in the context of how the safety is assured when it comes to disaster or when it's likely to happen. So we should have some discussion, detailed discussion about, not today, discussion about what potential risk there are and how, or if the risk becomes realization, and how we can try to escape out of the disastrous condition through the help of 6G technology. And the smart city is one of the important aspects. Urbanization, how we can make safer, sustainable community. That's a very important aspect. So out of these 8 verticals, I want to briefly go through some exemplary 4 verticals before I move on to use case discussion. So the first thing I want to talk about is industrial IoT. So as you see here, this is not really factory setting, but somehow logistics. In the 5G era, we have discussed how we can provide some automate the 5G technology support for Industry 4.0. So it is basically a caged environment for robotics. So robotics, the role of robotics is quite important in the context of Industry 4.0. But now this example especially shows that it is somehow out of the cage scenario. So even in the case that we have, manufacturing related robotics operated around certain sites, including this type of, this is not a caged environment. We should provide very safe, we should ensure safety measure where robotics or robotic applications work together or reside with the human worker or human being. So this is something we want to talk about. So we needed some, very, very nice and accurate decision making powered by or supported by AI technology, and also sensing technology quite important when it comes to robots and human or machine and human coexistence scenarios. And the next one is also a little combined with this, some overlap with this one in some context. But smart city is a more globalized scale for smart home and things like that. So we have many interesting things to support, not only for the engineering level goals, but also for the United Nations defined high-level sustainable development goals. Okay, here is one interesting aspect on the intelligent transportation system. That is also part of one of the United Nations SDG, which will be, I believe, touched upon by SAN Group Chair Amir Gomroki later. So, but basically what we want to pay attention to is that how we can enhance the feature that we have developed so far. For example, safety and situational awareness. Also, there is some comfort feature while this type of transportation system is being used. So this is what we want to try to improve. But there are 2 aspects we can think about. So, standardization aspect, we have developed many things, but you cannot really see these days in the market. Right? So we have 2 different aspects, 2 different arms, 2 different track of trends. So one is about commercialization, and the other one is about technology development in the context of standardization. So this one is a little bit focused on the standardization. So and the next one is about EGE, entertainment, education, and gaming. So education and entertainment is one of the few of the largest, biggest opportunity ever over globe. So we want to provide very immersive and useful means to provide education, high quality education, gaming and entertainment. Here, gaming doesn't necessarily mean the online gaming or virtual gaming, but also it might include some physical entity associated gaming. For example, the drone racing that is identified in one of our white paper. So we have cyber physical system related gaming as well. That really requires a very low latency, not only in one way, but also in multiple round trip time minimization or optimizations. And now, how much time do you have? Let me try to briefly go through. So this one is the summary of the white paper on representative use case so far. But next week, I believe you are going to see more of use case category in the 3DP workshop. So first one is about XR. The second one is about how we can collect data. And the third one is how we can provide the network-enabled machine or robotics and automotive systems in a way that we can help everyday living and experience and critical roles and high-level societal goals all together in an appropriate way. And the last one, but not the least, is a very interesting thing. It's a personalized digital experience that includes several aspects: shopping, traveling, and many things around for personal life during a day. So it's a I think very useful aspect or useful angle or influential angle that NJ has identified to provide some outcome for Senate body to think about. And the next one. So I'm going to have 8 slides, 2 representative use cases out of the 4 use case category. But in the interest of time, let me briefly go through the top, So the first 2 use case that I want to briefly touch on is about XR, multi-sensory extended reality. One is about education. I think we don't need to mention about how important the education would be in the context of we have many different type of teaching, learning, or education. So kinesthetic, for example, learning may require, we don't really want to bring our kids or students to the field. Instead, we can try to utilize advanced technology, especially for example in medical school, to provide truly immersive experience when they try to learn something. So we have identified some role players. The reason that we have identified the role player, same thing in the other 7 slides, is because we want to articulate some functional capability or performance requirements in the context of who does what and who needs to do what. So that's how we want to try to improve our recommendation, briefly summarized in the right-hand side. Then we are still working on the articulation activity. So I think it's quite interesting and important to get together, not only for NJ member, but also with the other alliance members to make those recommendations more mature. so that we can make more readily available candidates for standardization. That's, we believe, how we can suitably expedite the process so that we can save our resources until we can enjoy the 6G technology or services. So the next one is about gaming and entertainment. So similar features are needed. And the next two slides about how we can collect data, even in healthcare perspective, or in body, typically in human body environment, how we can collect data without making our body open. So, for example, we can try to utilize some small capsule or whatever, so that they can try to capture some image or whatever, and then securely transfer those information or data to external entity through the use of a relevant and secure mechanisms. And the next one is also about how we can provide safety measure in the way that we can utilize the 6G technology for smart city environment. The disaster preparedness is also important, and this one is about after something happens, how we can try, how 6G system can be a useful means for the recovery process. That's how typically public safety is trying to study. And the next one is about robotics and autonomous systems. So we have ITS here. So basically, the robotic system can be translated into a machine, remotely controlled or autonomously maneuvered type of device or machine. So we have ITS. We have some idea about the UAM driven by one of our member, used to be. So that's it's very valuable and promising area, we think. And also field robot for not only our rescue and search and rescue, but also for hazardous conditions. We should improve the quality of working environment for human beings. So that's very interesting aspect that we can try to study in the context of radio and networking technology. And for that, we need to have collaborative robots or group of robots working together. That means they not only need communication technology, but also they need to have their own coordination. That means if there are certain type of task that a group of robots can work together, then how we make them coupled with in a small group might be an interesting topic to investigate. So that belongs to somehow the research topic, but all together we can say they are the essential part that we can see those features in the market. Otherwise, it's not really. There might be some hurdle. Next one is also cobalt in agriculture. As you know, USA is one of the biggest food export country, but not necessarily. So if you have a vertical, that does not necessarily means that 6G system should have something out of that. There might be some different aspect out of some discussion, analysis, or whatever. But so far, it is what it is. So we can imagine that the collaborative robots, those operations are going to be an essential part for smart agriculture. Not only the agriculture per se, but also there are different kind of business model, which is agri-tourism. So there are multiple different type of role players together. And now, by the interest of time, let me try to briefly summarize this. So personalized digital experience includes travel, shopping, many things around. These are important and interesting aspects for the economy and especially for our daily living, assisted living. So it requires very intelligent functions. So AI ML, so sensing feature, robotics, and virtual robot function. Even virtual function can provide a useful feature for human beings that is very, very startup things, of the life. And this one is about shopping. So shopping is one of the interesting and important, market potential, right? So this one is also related to digital twins, many things. So very interesting and a unique feature. I can say this one is a unique feature that NJ has presented so far. So this is so with this I want to conclude my presentation. So these are some summary of the four foundational areas of use cases. So I want to kindly propose that Korea 64 member companies think about those aspects as well. And we can hopefully work together to come up with more mature level of recommendations that can hopefully expedite the standardization process so that we can see very valuable and promising 6G technology and services in the near future. Thank you.
Do we have any questions? Yes. So is this basically same to the contents gonna be presented the next week? Essay workshop by the NJ perspective.
I can say yes, but next week we are going to present a little bit more.
Okay.
So for example, I showed 4 use case category. We have 3 or 5 more. For example, LPWA, fixed wireless access, and digital twins, and things like that. So so that is, I think, important for people to think about because we have 2 aspects: standardization, but also standardization doesn't necessarily. It's important to key factor for commercialization. But sometimes, even though the standard is ready, the commercialization comes very late. So in that context, there should be some kind of compromise so that we can see the service in the market very soon. So we are going to have a little more than this. That's why.
So that's not only for the day one service.
So we are going to have many things, but we are going to give some stress about the day one feature.
Thanks.
Thank you. Any other questions? What? Yes.
Regarding this reliability condition, which is provided in the digital healthcare, and the 6.9 reliability condition is provided. So what could you elaborate what kind of reliability especially need to be applied in such a specialized application?
Yes, good question. So in 5G, 3GPP has already mentioned more than that. So even 6G, 6.9, 7.9. So, but they are all depends on some combined KPIs. For example, what about the latency that should come together when it comes to reliability or service availability, communication service availability. So we want to articulate specifically in what condition we should combine multiple different capabilities, such as latency, reliability, and the data rate all together. So those aspects are somehow considered in 5G specification in 3GPP, but it is not. We don't think it's enough. So we need to further need to articulate what kind of difference or combination of capability we need. So it depends on, for example, in-body condition. There should be very short range of communications, and if we have an LPWA case, then we have very long range of communications. But it will come with device density related capability. So that's how I can briefly reply with. It all depends on various type of applications.
Great, thank you, Ki-dong. Thank you. All right. And next, we'll hear from Jae-Hyul Kim to talk about vertical applications in Korea. Here.
So good morning. This is Jerry Kim from Energy Plus, one of the three Korean telecoms. I'm happy to talk about the near future application we are working on. So I'm talking about KUAM today, the Korean urban air mobility. And you don't cover the various aspects of use cases, and I'm going to talk about the specific vertical today. And Dr. Jae-Lee Kim will share with you other use cases as well. And to begin with, I think it's good to start with yesterday's conversation over dinner. Dinner was great. Thank you. Thank you. And we were talking about several use cases like extended reality and what's going on with Apple Vision Pro and things like that. And then Amir wrote a question that, what are you expecting from 6G as a telco? And it was a great question because I have been thinking about that for a long time. But as a company, we are not thinking about 6G yet. We are still monetizing the 5G. So I said, no, we are not expecting much yet. And then we move on to what can be a great application for the 6G. And I think UAM, urban air mobility, can be a great example. And also the societal economic things are also great examples too. So I think we are related to his topic later this afternoon. And I'm going to move on with the, what is the next slide? Okay. So we began working on the UAM since 2020 when Korean governmental agencies formed Team Korea, KUAM team. It's a multifunctional between the Ministry of Science and ICT and also the Ministry of Land, Transport, and things like that. Okay, so from 2020 to 24, if this is on provisional stage, we are preparing the, for example, concept of operation, and also we are doing grand challenges, 2 rounds of grand challenges, and then from 2025, we are going to start early stage commercial launch, and then move on to growth from 2030. So that's a kind of basic plan for us. Then, so what is it for? We are thinking of several use cases like urban transportation, as like air taxi, and also we are into cargo and also public safety and tourism. These are things that we are looking at currently. So I talked about the 3 stages. So after the grand challenges, we are moving on to early stage launch of commercial business. So with that, so we are thinking that pilot will be on board, and we are going to use current existing air traffic management system, and also the automation is just a basic level, and also we are going to use fixed corridors only. So because it's a very complicated, so we are going to use some fixed corridors, and then we are going to use some of the 5G aspect, but we are still using the existing aviation voice communications, and also navigation is working on GPS, and the vertiports will be only some limited spots. But with the growth stage, we are going to we are expecting some remote unmanned operation, and also from this stage, we think that 5G will be incorporated extensively, and also the corridors will be a kind of network. So there are several other points of interest that we can travel to and fro, and also the area network will be more 5G and 6G, and also we will be using sat, and also navigation will be not only GPS, but it will also use visual sensor-based navigation. So let me share with you what's going on with the current challenges. We are currently in round 1, which is working on the rural area. It's the southern part of Korea. And then from in 2025, we'll be moving on to urban areas. So near Seoul, it's like we have international airport in Incheon. So we are thinking of kind of use case like the passengers who landed in Incheon airport will be moving by air taxi to Seoul area, metropolitan area. That's a kind of use case. And when it comes to UAM's ecosystem, there are several participants like aircraft operation and flight service, and also in traffic management, and there should be some vertiport operator, and also maintenance and repair and things like that. And also very important part is the mobility as a service. This is because you are also using a lot of Uber or Lyft or some MaaS services, and this air taxi can be a great element that can be incorporated existing MaaS service. So the current service providers are not going to miss this opportunity, because that will make their service more useful. So these are the teams that are participating in the 2 rounds of grand challenges. There are 7 teams. LG Plus is participating as a UAM future team. We are collaborating with Kakao Mobility, who is providing the MaaS service in Korea, and also GSENC, the construction company. And SKT is also providing a great MaaS service in Korea, and they are also participating as a MaaS service provider in KUAM Dream Team, and so they are incorporating with Korea Airport Corporation. So it's a airport operator, and there are several other teams in Korea. So as a telco, we are going to provide basically the communication network for UAMs, right? So how we are working on the communication system, before we move on to that, maybe we'll have to see what's going on with the UAM. So UAM will be operating between 1,000 feet to 2,000 feet in the air. And that's the area that we never provided service before as a communication provider. So this would be a great challenge to us. So we did a measurement what's going on with the this airspace, and we thought sometimes we can use the side lobe of the antennas or something like that. So we did measurement, and we found that side lobe wasn't enough. So we need to have some other measures to cover the network in the sky. So as I said, U+ is building the area communication system. That's the #1 priority. And then we are also providing the UAM traffic management platform over that area communication system. That's the two goals we have. And as I said, Kakao Mobility, the mobility service provider, will be doing the seamless service, and then other multi-port and other elements will be also be ready by 2025. So about the UAM traffic management, there are a lot of complicated issues. So how we can manage the routes, and also how we avoid collisions and things like that. This is all in the future will be managed by AI and will be autonomously done. But before that, we'll have pilot for now, and then we'll slowly move on to autonomous driving. And this is the overview of what's going on with the communication system. So as I said, we did measurements over what's actual signal to interference noise ratio, and what's the handovers happening, and with the real situation. So this is the Grand Challenge #1 site, which is in the rural area. This is the example of the route we are building in the site, and we measured some of the routes with 5G cell sites, and as well as some upwardly tilted antennas. So we have two different networks, like one is for the existing ground network, and the other one was like tilted network over the ground network, and we can serve the area network as well. And you can see red dots, and that's the area network base stations. And also there are blue dots and green dots, which can be turned on or turned off to measure the rate of the data traffic and things like that. And we found out that even though we are trying to tilt and use upward antenna, but there was still some interference between the two, and there were some handovers happening unintentionally. That was the reason why we have to have 6G in the future, or some other configurations, to have a seamless and safe communication network for UAMs. So this is the basic diagram for what will be expected with the area network. So you are also very familiar with it. So satellite network and HAPS and ATG, and there are other components like UAV relaying the signal from the ground to other vehicles in the air. And this is what's going on with the actually the Korean research institute that they are heavily looking at the opportunity to have aerial network and relay the signals from the ground to other vehicles. And this is one of the great topics to study. And this is the KPIs of the mobile communication, 3D mobile communication for UAM and other non-territorial terrestrial communication. So we are thinking that users can use 1 gigabit, 1 gigabps data rate anywhere in the sky. That's the maybe #1 priority, because they want to, the passengers in the air taxi want to use videos or things like that. And also it can be like the coverage should be vertically like 10 kilometers up in the sky. And also the mobility would be 1,000 kilometers per hour. And at that speed, we are still achieving 3.3 bps per hertz spectral efficiency. That's kind of a goal of the research project. In my opinion, the UAM or the societal, public service can be a great example of 6G, because this cannot be so you cannot provide this service without 6G or 5G advanced features. And also there's a great, very important feature is that we need to have collaboration between the participants, like government and also telcos and also other business partners that achieve the changes in the society with 6G. This is one of our goals for having the KUAM service in the future. Any questions?
I have a couple of questions. So the first question, thanks for the presentation, because it is pretty good. The first question is that you rely on the side lobes for the from the CSPs for this operation, but are you also having dedicated antennas pointing upwards?
So yeah, that was the point of my talk. That not only the side lobe, it was not enough for us. So we have separate antenna heading toward the sky, like 30-degree or 40-degree upward tilted. So that's a separate antenna, not using the side lobe.
Oh, so basically, so from the vertiport, it takes off at say 30 meters and then goes to 2,000 feet or something like that. So initially, you will be communicating with the side lobes, and then as you go reach a stable altitude, you can then communicate with the antennas pointing upwards.
In my opinion, using side lobe can be, I don't know, but
as you
dangerous.
go up and up, you see more interference from nearby base station. So the point is, will you have a separate set of antennas, the CSPs, for UAMs?
That should be a safe setting for UAM. This is a very, very, this is kind of service that should be managed safely. Safety is #1 priority, I think. So in that case, we have to have a separate network of antennas, not for the ground, for the area. Yeah. So.
Question. So
just a quick question, clarification. I think you're actually using this not only for communication, but also for detection and communication. So you're going to detect, and therefore you need capabilities that today don't exist in 5G, and that's where JCAS and ICAS may come in.
Okay. Understood.
So I guess that this area communication uses the same frequency as the ground network communication. in this case, in your presentation, same frequency.
Yeah. So the example measurement, you mean?
Right.
Yeah, but that was done with the same frequency. That's right.
Do you think that no? Because I think no, due to the some interference between this aerial communication and ground communications, I would prefer some separate frequency.
Yeah,
bands.
of course, yes. So
do you perceive that would be possible or feasible with the same frequency for
no,
aerial communication?
yeah, I don't think so. Yeah, as you said, so the measurement shows that there are interferences, and that's affecting the performance of the network. So I would prefer to use different frequencies for the area network.
Yeah, thank you for a nice presentation. A follow-up question to the different frequency, specifically for the UAM network. Do you also believe this will be considered like an isolated or a private network where, you know, the regular devices in the terrestrial network cannot camp in,
So
and only the UAMs can camp in? Would you like deploy?
it's like the use cases shows that the passengers would like to use their devices in the vehicle, right? So that's the reason why we need 1 gig EPS for the passengers. So in that case, that means the UAM is not only the vehicle that's using the frequency, right? So the passengers will use the same frequency.
But okay, that's the UAM, but not the regular smartphones in the ground, right?
So yeah, that's right. So there are scenarios like UAM will be relaying the data to the device
Right.
in the vehicle, right? That's the case.
And I have one last question. So if I did the link, I did the link budget with 1,000 meter coverage. Around, we are getting around, say, 250 megabits downlink. Is that the desired data rate you're looking at?
I don't know the specific numbers.
I think 1 gigabit aggregate payload, not for each UE.
Then actually it's targeting on the
1 Gbps is the user experience
Yeah.
data rate, so it's a per user
1
rate.
gigabit, that's a lot.
Actually,
Should be supported.
those the numbers there, including the spectral efficiency. This depending on our deployment scenario, that might be changed later on. Now, that's our first target. When we start the phase now the contents nationwide 6G R&D project presented by the Dr. Choi yesterday. It's a phase 2 6G R&D. When we start the phase number 1 6G R&D project, that was the target number, but that might be changed. Like the
And for the UAM, it is all electrically operated, like by
Yeah.
Lilian.
Right.
Have you heard of the Lilian?
it's
company?
called eVolt, right? So electric.
So there are a lot of these companies. I know about this German company called Lilium.
It is a car company, right?
Lilium, no, it does UAM.
Yeah.
Lilium. Lilium.
There are many, like 5, 6, 7 companies that's just making the vehicle. And Joby is one of them, and SKT is working with Joby, and there is Vertical and
Yeah.
Supernal
And who is supplying the instrumentation? Huge aircraft.
Juice.
Yeah, the instrumentation for all the communication. Who is doing that?
That's not the information that I have right now.
Thanks.
Question? Yeah.
Yeah, I'm going to kind of lift this discussion up a little bit more to the relationships that resulted in this opportunity. Did the airline industry come to you with a problem to solve? You know, verticals are going to become very, very important in the landscape of 6G. So how did you arrive at coming up with this very specific application that is important to this particular sector? Did they come to you? Did you go to them? Did you?
So as a telco,
Yeah.
we are always thinking about how we can monetize the network,
Yes,
right?
yes.
So that's the goal
That's
we
how you
have
came up
right now. And also Kakao Mobility, the mass service provider,
Right.
they do not want to miss the opportunity. This is a great building block for them. And so say you are hailing a taxi service, and then after you take taxi to the airport or vertiport, and then vertiport will also have the reservation already made. That's kind of seamless experience, and you can travel to a certain point. So without this air taxi service, their service will be fragmented. So
So you partnered with these verticals to solve or create an opportunity.
yeah, exactly.
Yeah. And talk a little bit about the grand challenges. What happens at those?
So
You said they're competing in grand challenges.
Yeah.
Talk a little bit about those.
So we are showing that we can really operate a UAM service, for example, and the second stage will be in the urban area. So for now, we are not using the actual vehicle yet. So we are using something like called OPAV, which is somewhat a different shape vehicle. And in the future, we'll be using the vertically landing and taking off kind of vehicle. So this eVolt. And then after the grand challenges, we will be choosing, the Korean government will be choosing some operators for the next stage.
Okay.
So the grand challenge was established by the Korean government with
Exactly.
funding, and then these are the teams.
Okay.
to deliver.
So Green Challenge has the two steps, the two stages. The first stage, they select the 7 teams. There has been no filtering at all. Okay, they accept all the teams, and during the second stage, they will do the filtering later on, and their target to provide the service 27, something like that. So it's
Thank you.
quite much popular.
Yeah, thank you very much. Any other questions?
Thank you very much.
Thank you. Okay, and now we're going to turn to a discussion about migration from 5G to 6G. And oh, I'm sorry, one more. Oh, I apologize.
I had a great dinner. Thank you again. It's very nice to meet all of you. Yesterday's session was all good. Actually, I appreciate it. Today, basically, I'm the CEO of UCAST and UCAST Global. UCAST Global is US corporation. My company that provides the small cell solutions, total solutions. But I will talk about more practical point of view. It's a little bit away from the technology, and then what does market needs, and what is customer, what customer wants. So basically, everybody knows about it, right? 1G, 2G, 3G, 4G, 5G, 6G, right? Every like 10 years, everybody knows about it. From 1G to 2G, you analog cellular to digital cellular, you have more customers to support. It's good. 2G to 3G, on top of voice, you have data. It's good. And 4G, you have much better data rate, all IP-based data, and then voice is become secondary, but it's much better higher speed data. Now in 5G, but 5G is not completely independent of 4G because deployment is NSA, right? And then, so 5G is supposed to be eMBB and URLLC, MMTC, but where is IoT market? Still not active, right? And then how about the millimeter wave market? Still not so. And then even eMBB data rate is very high, but this is upper layer carrier frequency. Its coverage is not as good as 4G, right? So I see the 5G is not completely independent of 4G, and then 4G is still needed. Then at this stage, now we are talking about 6G. What kind of new technology? What kind of trend? It's very, very difficult to anticipate the market. So I just rather focus more on outside of those 3GPP technology migration. We can look at the market. One of the biggest game changers is shared spectrum. Shared spectrum, or some call it free spectrum, but not exactly free, but it's almost free spectrum. And then that shared spectrum is really the initiator of the vertical market. And also there's LEO satellite. LEO satellite, compared to traditional geo satellite, it is much higher data rate and much cheaper, and almost no round trip delay. And that also has a big impact. And also there's a smart city, it's a smart X market. And then also in the US, even United States, and about 3 years ago, there's infrastructure bill, like $65 billion assigned for the broadening coverage. So rural or disaster area coverage has become an issue. So people are talking about those digital transformation, including digital twin. Those are all outside impacts. Okay. So this is 6 vertical. I just got this from NGA items. There are 8 items. Everyone knows about it. So I tried to contact multiple US companies, US customers, and the Indian nations, and oil and gas companies, and state government, Department of Transportations, and Indian mining companies. And so public safety, we provide our system to Korean government. We call it SafeNet. In United States, we call it FirstNet, right? And also we have some trials in smart cities and 5Gs. So, and we also talk to the hospitals, and they consider like, and the anesthetics inventory management is very crucial for them, how to manage it efficiently. Also so there are multiple requirements from them. And then those verticals, before the verticals, normally we equipment vendors, we sell our systems to operators. Operators are expert, they're very good in technology. So we don't have to describe, or we don't have to explain much about our product. But we talk to verticals like, I go talk to Colorado Department of Transportation, but they wanted, I want cellular coverage. Okay, we have this road, your coverage is not good. So I ask Verizon, AT&T, give some more coverage, but they don't respond. This is quite natural because AT&T Verizon has no reason to provide that cellular coverage out of nowhere, right? But Colorado Department of Transportation, they need it. I need the coverage. And then I also want to use the same cell phone I have, right? So that's where the CBRS trial system can do. Okay, we install the CBRS system, and we provide the coverage, and then they can use existing their cell phone with eSIM or dual SIM. They can have FaceTime call. Great, they're happy. Now they talk to us. Okay, I want the CCTV without the wireline connections, because the CCTV wire connection, you need a lot of money for constructions, right? So wirelessly save a lot of money. So they want to do that. We provide that. Okay, they're happy. But So it's just like that, right? Also, we go to oil and gas companies, and then they need a connectivity, but they don't care whether this is 4G or 5G. I just want to have some smartphone or tablet. We have some three-dimensional thing, and then I see real-time alarms and real-time device management, all those things. I want that. So those are the nature of vertical customers. And then, so one of the requirements is that the system installation must be very simple. It doesn't have to be, if you conventionally like the big vendors systems like DU and IU, OCODU, or IU installations, the five installations, it is so expensive. And then key thing is it gotta be very simple to implement and very simple to, this second one is more important, maintenance. The part. So if that is wrong, then you just go there and replace the thing. So that will be the future of vertical market customers. So okay, I just this one to say that IoT for 5G is going on, so they got to be 6G, right? So as I mentioned to you, what's the definition of small cell? Actually, we provide a small cell, but small cell is not only for indoor, it also provides outdoor coverage. And the coverage distance is about the same as the big vendor's distance. The only different thing is the user capacity is smaller than big vendor's one, but in some way, this is very simple and easy to deploy, and then cheaper, and then also easy maintenance. We also, I'm also describe about network-in-a-box solution. I already mentioned this one. So the two big factors are your satellite and then share the spectrum. So this is conventional coverage thing, the mining, and then I mentioned the even in a lot of United States, they're just complaining about, I don't have good coverage, good cellular coverage. I want more cellular coverage. So I think in that case, the CBRS might be the solution to go. So this is one example of the Colorado State deployment. You see the small box. This small box, this is space station. So you just put the power and then put the power connection and antenna can touch it. You see weight is about 15 pounds. The power consumption is about 60 watts. So it provides the miles of coverage. So this is very easy to install. This is also the CCTV. This is Yagi antenna, Colorado Department of Transportation, headquarters of Colorado Department of Transportation, located in Golden City. So now I jump on to network-in-a-box. This is a kind of new concept. These days, this is quite popular, but the network-in-a-box concept started about 15 years ago in South Korean military project. South Korean, the army started to make a network-in-a-box based on the WiMAX system. This is 15 years ago. Now Korean army is using it so far, and then the weight of network-in-a-box is about like 200 pounds. And then it's very heavy, but now we make it LTE network-in-a-box, and then now we have a 5G network-in-a-box. The concept is like that. This is core network and service network and base stations. And this is 4G case, and this is 5G case, the same core network and applications, but you put everything within one box. So it has, and then it can actually, each HSS can it has everything. So what it means is if you're in the middle of desert or in the middle of disaster situations, within 10 minutes, you can provide cellular coverage. See, I also mentioned those still about the Colorado example. When the mother sliding happens about 3 years ago, and when mother sliding happens, and then the first net doesn't work because the existing, the fixed cellular out because the power is out, right? And then there's no way for them to communicate. So okay, so this is a conventional example. But one issue for network-in-a-box, okay, it has its own network solution. So within that network solution, with a couple of miles, maybe 3 or 4 miles coverage, people can communicate themselves. They can talk and they can send messages and push talk. Then how about backward? Backward is an issue, right? So the LEO satellite can be very good combinations. It's cheaper. LEO satellite $150 per month, or mobility is $250 per month, and the weight is very light. So this cascading system coverage is about 5 kilometers, and with the network in a box solution, the weight is 50 pounds, and then LEO satellite device is by maybe 3 or 4, 5 pounds. So power consumption is not much, and weight is very small. Then with this car, SUV, you can pretty much go everywhere, then any place provided cellular coverage. And then we also had we currently have the project with the Korean Army regarding, we call it ultra connectivity project based on 5G. I know the US Army is also looking for 5G network solution, but what we have been working with the Korean Army, basically I cannot disclose some details, but some of the key hint is that it uses drone. Our network in a box solution can communicate with the drone. So because if you are out of nowhere in the battlefield, there's no cellular coverage for sure. And then drones go there, drone get the video cameras, videos, and then drone cannot send the video real time to the headquarters because there's no connectivity there, right? The network in a box solution can provide the connectivity to drones. So in that case, you can fly like 10 drones or 20 drones, like out like 3 miles, 4 miles, then they can get the CCTV and real time get the feedback. That's one case. Another one is you can even put the drone, put networking box in the drone. We also tested this one, like up like 100 meters, 150 meters, your coverage is 3 or 5 times bigger. So you put that drone so higher, so you have 10 miles of coverage, within 10 miles or more of coverage, and people can communicate among themselves out of nowhere. This is also another case. We actually, Korean maritime police is using the network box solution in the ship. The big ship, mother ship, got the connectivity, and then it can communicate with daughter ship. Like 10 miles away, daughter ship can communicate the video also. So another one is, let's just say a lot of people are talking about the smart city. What will be the anchor of the smart city? And smart city, you have a lot of smart things, CCTVs and connectivities, and what can be the anchor of the smart city? One of the big candidate is street light. Street light is everywhere. So what idea is we put the 5G base station inside the street light. Sometimes you can also put the 5G core and base station inside the street light. And the power consumption is like 20 watt, 30 watt. It's a very small form factor. People cannot see that. Good thing for this one is that operators do not get the permission from the government to install the cell site, right? And then also power consumption like 30 watt is very minimum. People do not see that. We can still provide the full connectivities. And then actually we have done this project with the Telecom Brazil and the Julian Brazilian Lighthead company. It is combined with AI-based CCTV, all the sensors. The 2 places, Pato Branco and then Copacabana Beach in Rio de Janeiro. So this is 2x2 MIMO trial case, and it done this 1.5 years ago. It's been quite successful. This can be in that way, everywhere where the people go there, and you have some 5G cell inside. So nearby sensors, any connectivity that can be provided. So lastly, people are talking about the digital transformation. Like I say, whenever I talk to a customer, particular market customers, they actually do not know about what's 4G, what's 5G. They don't care, right? They just want some connectivity. I want this service, I want that service. So this user interface is also more appealing to them. So actually, this is FMS, EMS, RMS solutions we actually provided to construction area. We actually, our customers, Hyundai Development Corporation, this is not IT area, this is more like construction area. We actually have a BIM view. BIM is building information model. So now eventually that IT communication will be merged with construction the area, because a lot of people are talking about smart construction, and once the construction you have lifetime building lifetime management. So we have to use building lifetime management. In that way, you need all the sensors, and those sensors get wireless connectivities, and that wireless secure wireless connectivity gotta be provided by 5G or 6G, right? And good thing is that if we do not have a shared spectrum, every time we have to do this service, that we have to talk to operators, but normally operators are expensive, right? They're actually kind of reluctant to talk to them. But people say that you can have your network, you don't have to pay. Sorry for LGU Plus and sorry for operators, but actually, see, this is smart city. Actually, the guys, they just do not want to pay monthly service charge. Actually, that's the reality. They actually talk to me. How to, so the shared spectrum and gives that opportunity. I'm just like talking with some practical in front of you. This is the base, and then I have 1 minute just a video clip to see this fire situation happens. Could you like just 1 minute video clip?
We have a question here from America. Use the mic.
Thank you. Thank you very much for a very good presentation. I'm very interested in some of the comments you made in regards to CDRS. You know, CDRS is solely for the United States, 3.55 to 3.7. And it does have capabilities like SAS, spectrum access systems to coordinate access. Now in South Korea, you have you know, the same kind of capability in 4.7, if I remember correctly.
Yeah, we have 4.7.
And about 600 megahertz in the 28 gigahertz.
Right.
So if you could just share with us in terms of what has been the uptake in terms of the private 5G deployment using these, you know, private spectrums, let's say.
Oh, I'm sorry. What do you mean?
Adoptions, deployments of private 5G using this 100
US,
megahertz,
right,
600.
right.
And then the second question is that how the coordination is occurring, because there will be like conflicts, especially in those kind of scenarios.
Okay. In US, actually, the CDRS band is for both 4G and 5G. So yeah, people can use it. 5G technology can be used, and the 4G technology can be used. And then 5G, you need some frame structure, some modification, but it's minor.
That's not my question.
I'm sorry?
That's not my question.
Oh, you mean the South Korea?
Yes.
Right. South Korea is basically 4G is not allowed to use it. Only 5G is allowed to use that band.
So my question is that now that you have these capabilities in South Korea,
yeah,
like 100 megahertz in the 4.7, you have 600 megahertz to 28 gigahertz.
Right.
What are the, if you could explain to us, right, what is the ramification of that for the private 5G deployment adoptions, and what challenges do you see
in South Korea?
In South Korea.
Right. I think the one key thing is the price cost. Let's for example, like if you go to the customer, okay, you need $1 million investment. and they want, okay, can I get the $1 million back within 3 years? So it's very simple. Like if you like, it's a, so the first thing is the equipment, the total solution price has to be down so that because the customers, the price, so the budgetary thing. And then another thing is, so I think it's still so far the 5G total solution, the private network is somewhat expensive. So once you lower down the price, and then there possibly will be the market. But the situation in South Korea and US is different because South Korea connectivity is everywhere, right? So it's US is the lack of connectivity. South Korea people do not feel lack of connectivity. That's the biggest challenge.
Yeah, I think we'll have to continue this conversation over lunch. Thank you very much. All right, now we turn to Taki.
So maybe I can do some more.
Hello, everyone. Thank you.
Is it on? Do you see it?
Are you hearing me now? Yeah.
You turned it off, I think.
Thank you again for the opportunity, and thank you to the Korean delegation for visiting us, and thank you to the ITIS team for organizing this very nice workshop. So in this part of the presentation, we will discuss about the migration from 5G to 6G, the architectural and the deployment aspects. So the outline for the presentation starts with Next-G Alliance vision for 6G, the goals and drivers, also transitioning our vision for transitioning towards sustainable 6G. And then we will look into the possible architectures for migration from 5G to 6G and some key takeaway. So with regards to Next-G Alliance vision, David has already explained in detail. I will just add 3 main points before we go to the actual meat of the presentation. So from Next-G Alliance perspective, one main difference with Next-G Alliance and other organizations is that we focus on the life cycle for every stage, not just stop at the research, but ensure that we follow through until we have market readiness. That is the unique differentiator for defining end of decade 6G vision. And then with regards to the 6G leadership priorities, we also look at it more from more in a holistic manner, considering the innovative applications, the societal needs, economic goals, also the technology drivers, and also the governmental needs. And those aspects have been considered in also the Next-G Alliance Roadmap Working Group, arriving at the 6 audacious goals that has been touched on in many presentations. So here when we talk about transitioning towards a sustainable 6G, there are 3 main aspects to consider. I leave it to Bhushan to explain the details, but here I will talk about the 3 main points from our Green G working group standpoint. Where one is the observability, that is tracking the environmental indicators and also reporting it and using it appropriately to make the right choice. And that is the next point. With respect to making the right choice, and that starts from the research phase and also the standards and then the product development and also the deployment, making the sustainable choice for the design and development and the actual deployment. And last but not the least is the circular economy. The circular economy is also important in terms of ensuring that we reuse and recycle renewable materials, both raw materials, the product, and also the rare materials. Now we go to the learnings from 5G. So of course, before we actually look at the the migration architectures that are possible for 6G, it is also good to take a step back and understand the lessons learned. So the three main lessons learned. The first, from a specification standpoint, 3GPP specified too many architecture options. We had options 2, 3, 4, 5, and 7. I assume many of you can relate to it. The 2 was the standalone, and then 3 was the non-standalone, the 2 most deployed options. In fact, I would say the 3 was the most deployed options, and 2 is still taking off. And the other options are being other options were not deployed. And the second learning is also the slow uptake of the full 5G standalone system. And of course, while you could see this as a half empty glass or a half full glass, that NSA was a success because it helped adopt 5G very early on. But we could also see that NSA actually slowed down the deployment of SA, and at the end, of course, it resulted in a phased approach for most implementations. It took 2 different R&D implementation, and also in terms of deployment. Even if there was a migration from NSA to SA, and there are still networks that still remain only at SA. Still, we have only very limited SA deployment according to the GSMA statistics. And the last but not the least is the lack of 5G monetization. And of course, we have 5G has been successful in terms of EMBD and the classical services. But 5G was beyond that. 5G was targeted for MMTC, also URLC, IoT, and many other vertical use cases that were presented in the last 2 days. The actual enterprise and the vertical market takeoff has been slow. I believe there was also a question yesterday why we have specified so many features, but not many have been deployed yet. So this is the third learning. And now, considering this, we here list the possible migration architecture options for 6G. The first is, of course, a full standalone system. And then we have 6G, 5G VC with 6G control plane. And then we can also have, of course, 5G, 6G VC with 5G control plane. And then dual registration based, where we assume that the UE supports dual stack, registered in 2 different RADs simultaneously. And then the last option is dual steer based, where the UE is able to transmit and receive via 2 different radio access. So these are the possible options. And of course, there are other options. There could be other options, and this slide is not meant to be exhaustive. I would also like to add that this has not been discussed extensively within NXG Alliance, and we don't have any recommended or preferred option from an NXG Alliance standpoint. Since this question came up, as part of this workshop planning, we started to discuss as part of this presentation preparation with the NXG Alliance. So we expect that the actual supported options will be determined at the standardization phase. There are, of course, many factors to be considered. One is the spectrum availability, and that can be different in different regions. And then, of course, also the specification timeline. This also determines, what is specified first and what is specified next, and so on. So this, whereas NXG Alliance focuses more on the research and the technology aspect, so which is why we believe this is more a topic for the standardization phase. The first option on the standalone, of course, this is a very simple the assumption where we have a 60 radio and 60 core network, and then the UE also supports a full stack 60. The control plane is 60 based, and also the user plane is 60 based. And we also assume that the 60 features can be utilized from day one. And also would like to point out the native services are assumed to be supported in 60 directly, like the classical services like voice, emergency services, PWS, the SMS, and of course, EMBB and other features that are available. The next option is the 5G 60 DC, and here we assume that the control plane is anchored on the 5G radio. So the user plane is the 60 radio is mainly added as a user plane throughput boost, and here we can either have a dual connectivity between the 60 radio and the 5G radio, or we can have a carrier aggregation between the 5G and the 60 radio. So here we assume mostly the protocol stack is 5G based. Of course, the lower layers and the physical layer, especially needed for the user plane boost, would be 60 based. And this is equivalent to what we had as option 3 NSA during the 5G days. And then the third option is the 60 5G DC. This can of course be complementary also to the 60 standalone, where the control plane is on the 60, and 60 or the device also supports or assumed to support a full protocol stack from 60 standpoint, but 5G is mainly for capacity boost and also peak data rate aggregation. Here again, we can of course have dual connectivity between the 5G and the 60 radio, or we can also have carrier aggregation. The fourth option is dual registration. So here we do assume that we do have two full system in parallel, and the UE is assumed to support two full protocol stack, and also assumed to have the capability to transmit and receive on both sides, assumed to support dual stack. So it can do like for instance, voice on one side, data on the other side, or URLC on one side, UAV on the other side. I mean, it can be used for obtaining two services in parallel, or it can be used for obtaining one services, keep the other one idle and move when needed. So it is assumed that the radio access needed for a given user plane session can be decided at the time of the setup. So this is a bit static in that sense. We have a full user plane session in parallel. The next option is slightly similar, but there is a subtle difference. Here, this is referred to as the dual steer-based migration. This is also being discussed in CGPP in the context of dual steer devices in release 19 already for 5G. And this is a potential migration option for 6G when the UE supports dual RxTX, and it performs dual registration, but it supports a single service, and that single service can be steered via any RAT, either via the 5G or via 6G, both on the downlink and on the uplink. And here, the steering rules are more dynamic. It is not statically determined before the session is established. And here, the policies can determine where how it is steered, or certain other conditions can also determine how it is steered. Again, yeah, from next science perspective, we have no preference or recommendation, but wanted to highlight these possible technical options that exist. The key takeaway on the path to 6G, the first is, of course, we need to ensure that we have a sustainable 6G for the global good. And number two, we also think, for the success of 6G, we need to have strong collaboration between the industry, academia, and government, and across all the regions. And finally, we need a simple and a single-step migration from 5G to 6G to avoid fragmentation and also ensure market success with the 6G technology as well. Thank you.
Do we have any questions? Oh, here, let me give the mic.
Oh, thank you very much for the very insightful the information regarding the system architecture options. So there's a great impression from the group. And we actually have a very aligned view with some standard and non-standard modes, but still have some lots of options.
Yes.
For the non-standard modes. Actual form options are provided from you. So I just want to a little bit more elaborate on what can be assessed among the substantial types of non-standard need to be getting this more stress from the industry side. Could you provide some information?
Yeah, I mean, here, of course, yeah, as I mentioned a few times, we list the different options, right? But as a key takeaway, we need a single and a simple migration option. That is the key takeaway, right? I mean, within Next Year Alliance or from Next Year Alliance perspective, there is no specific preference. But I agree with you, this simple single option would be the right way to go and not have many options from a migration standpoint. And that single option must be decided as part of the 3GPP work.
Okay. So do you have preferences or priorities between the four?
Yeah, I mean, I must admit from Next Alliance perspective, this is why we had the disclaimer, no agreed preference, right? But of course, companies have different preferences. I can only say that, the standalone, seems to be largely assumed by many. But that's all I can say.
Thank you very much. All right. Different segment.
Hello, everyone. I'm Sang-min Lee from SK Telecom. In SK Telecom, I'm leading the 5G commercial base station development and access R&D, including the Open RAN and AI RAN and 5G advanced, and that kind of things. This is last presentation before lunch. I will do my best to shorten and efficient presentation. Yeah. So in this presentation, I want to share exact 5G status in our commercial network, and I want to share our thought and our consideration to 6G evolution. We had a lot of discussion and a lot of thought in our company with my colleagues. So I want to share our thought, our concern in this presentation. So I will talk about three things to exact to share the exact status for 5G commercial network. So in the first section, I want to share, and in second section, I want to share the brief outlook for 6G era, and lastly, this is the most important section. So I want to share our consideration and our concern. I want to start the story of our company. Actually, this year is so much special for our company. This 40th anniversary. So, actually, our company's history is almost the same in the Korean mobile history. Almost same. So, our company was founded in 1984. Our service was the mobile service with a car phone. In 1996, we started world first CDMA. And 2011, we started LTE Advanced. And 2019, we started 5G commercial network world first. So after 5G commercialization, next slide. Yeah, this is very complex. After 5G commercialization, we did a lot of things, especially I did a lot of things in this procedure. So we released 55 5G smartphone and 13 tablets. And top line is our major smartphone and major device. And bottom line is our technical activities in the 5G commercial network. I want to emphasize something. Our commercial 5G network is based on the NSA, but we are ready for standalone also. In 2020, we made the readiness for standalone, and we completed the test in the standalone network. And about the millimeter wave, we also got the readiness for the commercialization, and we are also provide B2B service with some smart factory, but for millimeter wave, we return back to government last year. All Korean operators return back because the coverage expansion is not easy, and there's some difficulty to find the business model. Yeah, that's the reason. Lastly, the end of last year, our subscribers, number of subscribers is about 16 million. It is the penetration, 5G penetration loss at late penetration rate is about 68%, and very high. That's our status. Yeah, I want to share more things. As I mentioned, our penetration rate of 5G subscriber is 68%. It is top level in Clover, as you know. And for the network performance, it is also top position. Annually, Korean government tests 5G field performance. It is about 1 Gbps in the average speed. Is actually very high speed comparing with other country. Last one is coverage. Actually, the end of last year, our government announced the 5G nationwide coverage. Actually, this picture is the status of the 2022 status, but now all red dot it was filled in the last year. So yeah, we skip this page. This is about 6 forum. Actually, this forum is leading the all Korean 6G R&D activities. It has been a great role as a focal point of Korean industry, academia, and research institute. About 150 experts has the activities in the 6 forum. It has a great role in Korea. Yeah. So I want to share I want to talk about the 6G. Actually, I think you are very familiar with this figure, but there is one interesting thing. I think somebody doesn't know the trend cycle. As you know, we are here in 5G, so every generation takes 10 years. But one more thing, there's a 20-year cycle. 1G and 2G for voice, as you see, data, 3G and 4G for data service. So it takes 20-year cycle. So in 5G, some immersive service and vertical expansion happens, but it is very limited. But many people think they can be popular in some days, maybe. So we think based on this 20-year cycle, maybe in 6G era, some new service can be popular, maybe. And I think this is the popular candidate of 6G service. The UAM and autonomous vehicle can be based on can provide the customer freedom from space and time. And Metaverse and XR is also a candidate in the virtual world using digitalization. And AI and robot can be a good candidate for the 6G new service. So for this 6G new service, I think the most important thing is the timely resonance between the innovative device and network performance. For example, the 6G use, many people says all kinds of service for the 6G candidate. For example, for UAM, I think few years later, a UAM vehicle can be an innovative device for 6G, maybe. So, and it can make some timely resonance with the 6G high performance network. So, if it happens, it can be a good killer service for the 6G. So, I mean, the keyword is timely resonance. Also, XR can be a good candidate. I think a few years later, some new XR device can be can come. I think it should be better than the Apple Vision Pro. So that a new innovative XR device can make some timely resonance with the interactive real-time 6G high-performance network. So, yeah, so that's my thought. For 6G kilo service, timely resonance is most important part. Yeah, we published a 6G white paper last year. This white paper includes our 6G consideration and key technology and our vision, and especially this white paper includes our lesson learned from 5G. So we think the three items for the 5G lesson learned. The first one is the killer service. Actually, we didn't have the killer service for at the 5G commercial launch time, and so many customers cannot feel the differentiation between the 4G and 5G still. So that's our first lesson learned in 5G. So we really don't want to make in 6G again. And second is the public misunderstanding for 5G. That it is caused by actually our overcommission of the 5G performance. We said everything can happen in 5G. Powerful performance. That was overcommission. So so in 6G era, we think that we don't have to, or we should not. So we have to say the real things to customers. Customers should understand the exact status. That's second item. And the third one is also important. Third one is the closed ecosystem. So in 5G era, the major base station vendors' power is increased. I mean, the local vendor and mid and small size equipment vendor, the marketing share was decreased in 5G era. So we think in 6G, the so-called open LAN will be important to expand the ecosystem, not in the major equipment vendor. Yeah. So yeah, for 6G migration, I will talk about the service and spectrum and migration and AI. That 4 slides remains. I will do my best. The first one is the service. Our focus service is these 3 things. First one is AI. Actually, someone can misunderstand our intent. I mean, the AI can be used to enhance the 6G performance, but that's not what I mean. In this slide, the focus is AI enabling. I mean, the 6G infra, we think 6G infra should provide the AI enabling function, AI computing power to the customer. that is what I thought, what we thought. So we think that it can help the customer our monetization, and it can be a good use case. We think so. That is our first use case. And second is the sensing. We think the 6 spectrum will be higher and higher, maybe, because the lack of spectrum in the lower side. So using the high spectrum characteristic, sensing can be a good use case. It recently, combining with the AI algorithm, the sensing performance becomes powerful. And third thing is about the coverage expansion to the sky. We think in 6G era, mobile network coverage can be expanded to the sky for the UAM and drone. So it can be also important use case for the 6G. Yeah, this is about the spectrum. For the spectrum, I think almost all operators think same thing. Maybe the lower frequency band is better. Yeah, that's the simple statement. But lower spectrum is better. That's the fact. But there's a lack of the bandwidth, so we have to find the higher bandwidth, higher frequency. Yeah, but in this stage, anyway, the initial stage in 6G preparation, the sub-terahertz is important, but was the important keyword, but now it is not. So the spectrum is also the most important part in 6G preparation. And the other thing is for migration. We think the 6G use case is somewhat unclear these days, and traffic needs and service explosion is not expected yet. So we think the 6G nationwide coverage, we cannot imagine that. So in this situation, we think we don't have to hurry up. We can prepare the 6G migration with the traffic needs and service maturity aligned with it. So we think the 6G migration will be not the generation change. We think it can be a generation mix. I mean, in our company, many people think the 5G can be a last generation for the nationwide. Somebody's thinking. Not everybody, but so in that sense, for the 6G, this generation mix technology will be important. For example, the multi-rate spectrum sharing and network architecture to use 5G and 6G and dual stack, that kind of thing. That kind of the generation mix technology will be important. That's what I thought. Lastly, this is about AI. as I explained before, usually people think the this AI assisted infra. AI assisted infra means the performance enhancement and operational efficiency, stability based on the AI model, and that's the basic line. But we have to add number one, AI enabling infra. This means the infra can provide AI computing power and AI infra for the other customers, and that's we call it the AI enabling infra. In 6G era, we think we have to think both of them, number one and number two, and so we think that's the way forward to 6G migration. Yeah, this is the end of my presentation, and thank you.
Thank you. Thank you. You have questions?
Yes.
Thank you. Maybe you should go first. Ladies first.
Thank you. I had three small questions actually. The first one on the statistics that you shared on the 5G, 63%. I wanted to understand, was it considering both NSA and SA or only SA? The second question on the AI use case, do you foresee basically the compute would be done on the cloud or the network side, and that is how the network or the 6G network can be the AI enabler? So you foresee that the 6G can be used as a technology to offload this compute power. The third small question is on the follow-up on the traffic. I mean, if the 6G network can be an AI enabler, wouldn't that actually be the traffic generator, right? Use case for 6G.
Okay. So the first question, actually in Korea, all operators is similar. All our service is based on the, especially B2C, the NSA. So some B2B use case exists, but very small. So I think the number is all about the NSA. Yeah. So, and the second question is AI enabling infra. We think that I think you already knows the GPU based VLAN, virtual LAN, from the NVIDIA and SoftBank, blah blah. And so it is similar to the kind of things. The virtual, for example, we don't think the GPU should be included, but we think the virtual LAN with the CPU or GPU or NPU and that kind of things, they can provide the computing power for the other service, especially in nighttime for the kind of monetization using network infra will be important, maybe next generation. And so the question, I don't remember. What is this?
No problem. On the third question, I mean, one of the considerations that you had for the migration architecture, right? I guess you had mentioned we don't foresee that the traffic will actually need a 6G network to be widely deployed. I was just wondering if you see this AI enabler could be one of the use cases that would actually benefit from 6G and be the killer use case for the 6G itself to deploy a wide area network.
Okay.
All right, good. Thank you. Sorry, I didn't know if you wanted to respond to that, if AI is the use case or a capability or enabler, but please go first and then I can ask my question.
Actually, sorry, I cannot catch the point of third question.
Yeah, I guess in the migration slide.
Migration slide?
Yeah.
Here?
Yes.
Yeah.
The first bullet point on the service or the traffic demand is not expected to increase significantly. The 6G builds upon, right?
Here.
Yes, yes. I mean, wouldn't AI help with that? To make sure that the traffic increases? Yes.
Actually, we don't know.
Okay.
We don't know. It is unclear. So I mean, that's our based on our guess, maybe frankly speaking. So we think we think AI can be a good candidate and most important candidate, but we think we don't know it can explode or not. So if it explodes, we can change to generation change. If AI use case explode.
All right, thank you. A very quick question. I only have 7 parts to my question. I don't know. Is it on?
It's lunchtime.
Yeah. All right. Thank you. So, very quick question. Your observation in regards to 5G and what the customers' feedbacks are. Right. I want to dive into that for a second. Especially in South Korea, the customer experience is extremely important. That's my understanding. And actually, the CSPs are at the mercy of the customer experience because customers can easily change from one CSP to the other. So in terms of 5G, do you think, or do you have data to support that actually the customer experience is higher, better? Number one. And number two, as you know, 5G deployments are in the very first release of 5G. So things that have maybe the marketing was overzealous. Do you feel or think that by the time 5G release 20 comes along, still we have not been able to capture what 5G had promised?
Very difficult question. Actually, in this question is about the marketing perspective, maybe. So I cannot answer exactly. So
is the customer experience better or worse with 5G?
It is better. Definitely. Yeah.
There you go. So the first release is actually you have a good customer experience. Now you have 5 more releases that are going to come.
Okay.
Yeah, I have a simple question. So from a CSP, Korean CSP side, SKT, why are you excited about 6G? What are the features in 6G that are getting you excited? Thank you.
Actually, I don't know the Koreans' opinion, but in my personal opinion, I think the 6G is the natural way to we go in 2030. So our work to do is prepare the next generation. That's what we have to do. So that's my view of the 6G preparation. So we think in 2030 network, we have to make some special use case and make the way how to monetize the customer service. We have to prepare the kind of thing for 2030. That's my thought.
So if I just give you more bandwidth, can you not do with 5G?
Yes. Okay.
Same question goes to NJ.
Very clear question about some RAN spectrum sharing, and I just needed some more elaborate operation, especially in the general design. This is a temporal switching in the given spectrum, so we then to automate that. The temporal, the radio node can operate with the 5G mode, and it needs to be a switch to the. I still have some real meaning of RAN spectrum sharing you mentioned.
You mean the MRSS, multi-rate spectrum sharing? Actually, we don't know the 60 use case and 60 traffic explosion is unclear. So we think the spectrum sharing is very important. For example, we have already the 5G technology to spectrum sharing, like the DSS, dynamic spectrum sharing, but it has a lot of the overhead. Maybe it's around 10% or something. So in 6G era, overhead should be, for example, less than 3% or something. So we can use the same spectrum bandwidth for the 5G and 6G together. So we think the kind of technology should be prepared for the 6G era. That's the point I said.
Thank you very much.
It's better. So yeah, so let's see. So this way. Okay, all right. Yeah, so what can be enabled with AI native air interface? I think we listed 8 use cases here inside our 6G network. The first one is channel feedback. This one we discussed. Many of you are familiar with. It has been, it's been released 19 study. Beam management is already a work item. Release 19 was specified. MIMO symbol detection, constellation design, nonlinearity, neural receiver, channel estimation, and reference signal design. All these are, these, I'll say 1, 2, 3, 4, 5. These 5 topics. Maybe I'll say, let's look at on the right side, these 4 topics. These are hardcore layer 1 physical layer implementation. Right? So these hasn't been discussed yet because from hardware perspective, you can think of beam management and the positioning. These things are done in software, pure software. Right? These things can be done on the millisecond, millisecond time scale in terms of processing. Channel feedback, because of the timeline, it needs to be done in millisecond time scale. And for the 4 topics on the right hand side, this needs to be done at the symbol level. So this is we're talking about tens of microsecond time scale. And then the bottom left, nonlinearity and impairment, this needs to be done at the sample level, nanosecond. So just so from the ease of practical implementation perspective, right? We picked off the easiest one, beam management and positioning. And I said these things doesn't need to be processed at a higher layer is enough for our fingerprinting stuff. And then we're discussing the
state feedback is a sort of low MAC, high-fi, and then the physical layer ones and the symbol level ones will take their time. So I don't expect 5G to address those questions. Those will be hard for 6G questions. But as you can see, this AI native air interface sort of have an evolution path going from the simplest, the softest solution that's potentially can be implemented to very hardcore. You need a hardware update, right? Down to the silicon level. So you cannot just put in a GPU and think things can be done. It's actually in the basic. Okay, and what's needed to enable this AI native air interface? There are three big problems we address here, and one is autonomy. Autonomy is basically you want to this air interface to be continuously updated, make real-time decisions, and this is very different from ORAN. We're talking about non-real-time, near real-time operations. All these are in it's real-time operation. Right? We already talked about the time scale from the last slide for different use cases. The second, so that means you need hardware. The second one is need to be continuously learning, because the only power of AI, we all know, is data. So if you just do it once, the amount of gain that you see will probably be limited. So continuous learning will give you probably most of the gain. And we also have this concept called dynamic air interface, which means the current air interface is written in the spec. You open the page, you say, hey, this is what I need to implement. This is what the system is. Every 1.5 years to 2 years, another release, you open up the page and see if this line has been changed and the technology changed. ML is different. It's data driven. So you could have a framework put into the first release of 6G. You never change that line of code, but the system keeps evolving because implementation is changing, right? So today you have CNN, tomorrow you have transformer, and then the next day in some other time series, right? Some diffusion models that's coming. So without changing a line in the spec, the system is keeping improving. And also data is changing, right? Depending on what you trained and however you use it. So this continuous learning is a key aspect of 6G. It's allow the technology to evolve without the sort of cadence. And then near real-time optimization, yes, it does allow you, this is called temporal domain optimize. I think I talk about it's a long-term, the spec is evolving, but it can also adapt the data in almost real-time sense to give you optimization. So there are bigger challenge that comes with all the benefit we talk about, right? We said it's data-driven, it's optimal, and give you so many performance gain, but how the hell to test it? So in NGA, we talk about the conformance part and performance part. In my mind, conformance part is much easier, although it's still a new problem we need to solve. But from conformance part, you just need to test the functionality. Say you have hardware engine to do this type of inference, right? I can, tomorrow Roland Shorts can define a test case and put out some tests, and just to check you are capable of doing inference of a particular model. But performance is much harder because here, to take advantage of ML, it need to be adaptive spatially and temporally. For different vendors, they can have different implementation on the other side, right? So specifically in 3GPP, the terminology is called two-sided model. Air interface is two-sided model. You can find the interface between the network and UE. So if you test it with the TE vendor, it's meaningless because Nokia, Ericsson implement completely different stuff on the Genomic side. So your UE need to, although functionally, you can do, say, hey, this is 16-layer transformer with some MLPs. And you have that structure, but that particular neural network will not work with either Nokia or Ericsson's PlayStation or Samsung. So performance testing is very hard. So this is a problem in 3GPP we're looking at. It's called I think model pairing. Right? So and model pairing is the first step. So you know these two actually work together, have some baseline performance. Then you have lifecycle management. You need to monitor the model drift so that in performance, one particular model is no longer applicable. You want to drift to another, switch to another model. So it's a very complicated question. This is something SwitchPB hasn't done before. So whether 6G is AI native area interface work or not, in my mind, it's not about the previous pages on which use cases you gain, how much gain. It's this line. Whether it works or not depends on this line. If it is handled, it will work because with data we can always optimize. So the next is dive a little bit detail into the testing. So data, because AI models are data driven. So how do you design the data set? Who owns the data? You know, how it's used for both the design, the training, and the testing. It's a tricky question. So, but this is a specific problem from the previous page for testing. So move on. Semantic communications. That's another probably a little bit more futuristic topic that NG has. Right? So it's a very hot topic. So what NG discussed is on the right-hand side, talking about how we can harness the power of generative AI and semantic learning. On the left side, I added just the definition of what semantic communications, right? It's actually defined in 1949 by Shannon. So what we have been doing is this level A communication, which is to deliver the bits. Right? This is the Shannon bound that information theory will, where information theory also have level B and level C. Level B is deliver the meaning, which is semantic communications. But even more advanced version is level C. Level C is you don't even care about the meaning, you care about the consequence. Right? So give you a very concrete example is for many of you in row one, you will know what I'm talking about. I have a PDCCH, right? It's downlink control channel. For level A, what you do is say, I want my packet error rate blur to be less than 1%. Level B, what you also, I don't care if 1% or not, right? So what I want to know is what my assignment is, right? So it's I want to understand what the meaning is. Level C is why do you care about even the meaning? What you want is you actually able to deliver the the whole control loop should be closed. But even if you don't understand the meaning, but if it doesn't hurt your performance, get lost. We don't care. So I think this is sort of semantic communication is where it's the intermediate step where we can potentially do joint source channel coding, right? So if you read the papers, all the people who are doing semantic communications are cheating. They're just doing joint source channel coding. What they do is saying, hey, like the channel state feedback, CFI, CSF, instead of delivering the bits of the PMI perfectly, I only want to know the quantizer level of the channel. So why don't you just tell me what the channel is? I treat it as an image compression problem. We don't care if the bits are delivered properly. We want to make sure the MSE or the error is low enough. So effectively, I think the first step we can do is joint source channel coding in the area interface to take advantage of semantic communications, which AI is able to help us do. The next one, I think these are the open areas for AI research for AI native area interface. We touched upon a couple of them. I think that something new is this sustainability, and it's something that we need to pay attention to. Many of you, I think, discussed offline. Training is horrible. For LLMs, for us, it's not too bad. We're not training something with a trillion parameters. So, but again, still there might be a cost to it. And the last one is responsibility and explainability. So you need to establish causal sequence of what's affecting what instead of the black box. This is another white paper we wrote on this SMO, it's just a monitoring and orchestration in terms of overall section network. One chapter touched upon ML. So how do you run ML inside the network, right? So then here are the very specific problems you need to emulation environment before you run the model, right? You actually need to emulate it. You need to understand the performance. Do it, right? And data handling, use it as a service, device management as well. For these all the AI services. So these are the topics that we're discussing in G. So that's it. That's my last slide. Thank you.
Do you have any questions? You have a few minutes.
I have in a hurry. One first question is, I'm pleased to see that you were suggesting that some test function and procedure in the page, but still have some numbers pointing to whether it should be facilitated in the 3PP standardization manner, and still there are lots of controversial situations between the members of different opinions. So still hard to getting the consensus for the such functions. How do you feel about that?
Yeah, absolutely. Like I said, if you solve the problem, then we're done. It's not about if you algorithm, right? So I think it's just most people are fear. Naturally, everyone's afraid of something that you don't understand. Right?
But still have some information feeding.
It's a matter of time. I think it's a matter of time. Now 3GPP in round one, if you go to the floor, you see people agreeing on a lot more things compared to last year. I think, it's a very tough problem.
Yeah, and then my final question is semantic communication. There, I'm pleased to see your proposal, but my understanding that they'll need some framework towards communication. So, how do you feel about some back knowledge representation is somewhat shared in the pre-stage? So, how do you think about some such as basic frameworks regarding the semantic communication? What is the standardization?
That's a very good question, and I don't think we have the answer yet. But the simplest way, instead of going all the way to semantic communications, just treat it as a joint source channel coding problem, right? Like all the professors who are doing it in 3GPP, there are many channels in the design, right? So I think cross-layer to talk about actually someone send the image and through communication channel, you just say, oh, it's a rabbit. No, that's not what we can do. It's layer violation. It doesn't work. We know it will never happen in our network. But if it's actually something that's happening in 3GPP in the run network, we know exactly what the meaning is, right? We know we don't have to do cross-layer violation for all the control plane stuff. Semantic communication matters, RC and all this other stuff. I think as long as it's in our network, we can use semantic communications. That's my suggestion. All right.
Thank you. Doug, you get the last question.
Okay, sounds good. Joint source and channel coding. I really like that idea towards semantic communications, but I've also heard there's a lot of resistance to that. I think because like 10 years ago there was a push for that, and a lot of researchers there were burned and just don't want to address that anymore. I'm just kind of curious. Have you seen any kind of pushback on joint source and channel coding?
I think general source channel coding, we know, anyone know information theory, right? You know the separation theorem. There's nothing to be gained. It's optimal to design source coding and channel coding separately, right? Based on information theory, we know the caveat is the feedback channel. If there is a feedback channel in there, then there's something optimized that can be done. But I think the biggest actually challenge is about layer violation, because my encoder, the source coding is happening in the app, in the internet. My channel coding is happening in the base station. There's no way we can do anything. But I think if you limit your ambition to some very small problem, like I said, PDCCH, CSI, or RC configuration, then it's actually tractable. Actually, there are, because we have suboptimal implementation, although information theory tells us there's nothing to be gained, but for our lousy implementation, actually, there are a lot of things on the table we can gain.
All right, okay, great. Thank you. Thank you, Ting.
All right, next up, we're going to hear about 6G technologies from the perspective of the National Research Project by Young-Do.
Good afternoon, everyone. I'm Young-Do, working at S3, KRI. In 6G forum, I'm the chair of 6G Technology Committee. And my talk is about 6 technologies from the perspective of national research project. So I'm going to share what technologies, sort of technologies we are studying now, and what technologies we are going to study in the near future. So the Korea 6G research, exactly speaking, is a state-funded nationwide 6G research. Well, it can be divided into 2 parts. The first phase of 6G research started in 2021 and will continue until 2025. This project is centered around 6 technology themes. All starting with hyper performance, hyper broadband, hyper precision, hyperspace, intelligence, and hyper trust. And I think this project has 2 main areas. One is utilizing very high frequency bands, sub-terahertz bands, and achieving very high data rate with target peak data rate 1 Tbps. And another one is so-called 3-dimensional spatial communication, extending the coverage of wireless connectivity up to 10 kilometers from the ground. And technology-wise, what even highlights the integration of terrestrial networks and non-terrestrial networks, satellite networks. And then the second phase of 6G research has started this month. So it will continue until 2028. And if you look at these terminologies for this second phase of 6G project, terminology is relatively humble and down to earth in some sense. So the second phase project is more about practical aspects, such as ease of deployment, low cost, and flexibility, and sustainability. It covers the upper mid-band, extreme MIMO, and open LAN architecture, and AI-powered communication and integration of sensing and communication, and energy-saving solutions. Government strategy is actually similar to the one that they had for 5G. It's early demonstration of 6G and early commercialization. In 2026, Korea is planned to show pre-6G demonstration, and maybe not the world first, but all the commercialization of 6G around 2030. Another important project, large-scale project. Well, from the perspective of our research institute, maybe this is the most important research topic. So complete, LEO satellite communication development. This research project is actually at the preparation phase
right now, and it covers LEO satellite payload technologies and intersatellite links, high throughput intersatellite links, and advanced ground systems, including gateways and ground terminals. Yeah, I like to skip this one. So key features. So from this slide, I like to give our views on key technology features for 6G. The first one is AI-powered communication. Basically, is expanding the reach of AI to air interface and radio networks. And currently, the hot topics under study shown here is already actually has been studied in 3GPP, and some of them are, it is actually start as a work item in 3GPP. CSI feedback and positioning accuracy improvement and self-organized networks. These are the hot topics currently under study, the ongoing 6G project. Another key feature is ISAC, integrated sensing and communication. This is a newly emerging area in recent years, and we expect this will be a key feature of 6G. And personally, I think that ISAC will be the one that can distinguish 6G from other generations, previous generations. So specifically, ISAC can be used to obtain high positioning, including range, velocity, and angle, and it can be used for the detection of object presence, and even it can be used for creation of images and maps of surrounding environment. So yeah, maybe this is another key feature that we are particularly our research institutes emphasizes is the close interworking between terrestrial networks and non-terrestrial networks. And the research topics include TN and TN integration protocols, so enabling smooth integration of ground networks and terrestrial networks, and also the seamless handover between them. And long range and high Doppler radio access technologies for NTN, and that can address the challenges caused by the long distance and the varying satellite speeds. And satellite payload technologies, a robust payload technology that can withstand harsh space environments. So as for the spectrum usage, well, basically we need more spectrum to accommodate the ever-increasing traffic demand. And recently, I think it's almost consensus that we need a primary carrier of 6G to be located lower than millimeter wave. So we basically support the layered spectrum usage approach. Here, high band millimeter wave and sub-terahertz bands can be used for sensing and ultra capacity, and the upper mid band 7 to 24 gigahertz for coverage and extreme capacity, and mid and low bands mainly for coverage. Regarding upper mid band, where in Korea we have these three candidate upper mid bands right now: 7 to 8, 12 to 13, and 14 to 15 gigahertz bands. And we think that for data rate, to provide high data rate, we think we need at least 400 megahertz bandwidth in the upper midband. Maybe that will not be contiguous bandwidth, probably will require some carrier aggregation like this. Well, this is the sub-terahertz communication. This is the one of the research topics, the ongoing 6G research project. The target frequency range is 100 to 300 gigahertz. The main focus is the multi-point transmission and reception, and development of a waveform that is suitable for high frequency bands, and solutions for the RF impairment compensation. And actually, we have developed POC system last year, and we demonstrated peak data rate of 100 gigabps at the end of last year. Regarding wireline networking, key feature of 6G wireline networking will be time deterministic packet transmission and its application for large-scale networks. And we've been developing the time deterministic technologies such as DESNet and time-sensitive network mechanisms since 2019. And now we are engaged in the standardization of them and developing 100 gigabps packet forwarding engine. And in 2025, next year, we plan to have a POC trial, which guarantees the very low latency, under 5 millisecond latency over a distance of 800 kilometers. Next one is again, the integration of TN and TN. And now we are developing dual steer technology, which is basically multi-connectivity of TN and TN. And we're now standardizing this dual steer technology in 3GPP, which is being carried out by 3GPP SA. And we are developing optimization, network optimization simulators for performance analysis. And also, we are studying clustering of satellites to improve the throughput of LEO satellite. Regarding hardware components, the key area is RF chips for sub-terahertz, specifically 140 to 160 gigahertz frequency range. We're developing a CMOS-based beamforming chips. And for 28 gigahertz bands, we are developing gallium nitride-based power amplifier with these characteristics. Now I briefly describe the future research topics of the 6G national project, which corresponded to the major research topics of the second phase 6G research in Korea. And we grouped these research topics into two parts, terrestrial and non-terrestrial parts. The non-terrestrial part, again, LEO satellite, payload technologies, specifically the payload RF antenna, the multi-beam-based array antenna and beamforming technology, and modem and software that can be used on LEO onboard processor, and inter-satellite link laser communication for enhanced throughput of LEO communication. Regarding the terrestrial network part, I think the outstanding topic is upper midband MIMO, extreme massive MIMO, where we're gonna employ thousands of antenna elements, and we are going to use the analog and digital beamforming for capacity and coverage. And we also plan to study cloud-based virtualization, virtual LAN, and the low-fi modem for O-RAN. The low-fi modem is part of a radio unit in the O-RAN architecture. And of course, area sensing and communication. And we are planning to conduct the research, the coverage extension technologies, configurable intelligence service and network controller repeater, and multiplex. And AI native RAN and mobile core is a continuation of the first phase research topics into the second phase research. Okay, and this is the last slide. This is our plan for 6G POC demonstration in 2005. It has it consists of two parts. The first one is ultra high resolution immersive interactive service. We are going to showcase wireless connectivity of 200 gigabits, and while line networking, we are going to show this 5 millisecond, less than 5 millisecond latency over a distance of 800 kilometers. The second one is so-called gigabps level TN and TN integration based three-dimensional coverage, where the UE is simultaneously connected to the base station and the satellite. But in here, the satellite launching will not be feasible within this timeline, since this demonstration is happening next year. So this satellite path will be emulated. Okay, this is the end of my presentation. Thank you.
Thank you very much.
Thanks a lot for a great presentation. My question is, with all this fantastic technology that you're envisioning for 6G, what part of that are you going to use or target for addressing the digital divide?
That will be
the LEO?
LEO. Yeah. So TN and TN integration include this LEO satellite communication networking. I think that needs to address the P35, and also the providing coverage for unserved and underserved areas.
So two questions. The first question is that you said that Korea will launch their own constellation. How will it compete with Starlink and Kuiper? Well, although they are for fixed services, but Starlink will do direct to device. That is the first question. The second question, what I have in mind is for the TN and TN integration, what kind of core you envisage? Do you want a separate core for TN and separate core for NTN, or a joint core? Thank you.
Regarding the second question first, but basically, one of my slides describe the multi-connectivity and terrestrial networks and terrestrial networks. I'm studying not just the separate, but also the specific communicating data through these two networks simultaneously. And the first question is about competitiveness. But actually, this project is not about competing with this large-scale LEO satellite communication networks that are already, being installed right now. I think it's the purpose is more about technology research and more about the providing some foundation for payload technology, etc. So it's not about.
So you'll be doing regenerative or transparent for this constellation?
So we were, due to the limited budget, we are not going to have a very large scale satellite launch. We're gonna have as far as I know, 3 or 4 satellites.
Oh.
Any other questions? Thank you very much.
Thank you.
All right, next we're going to be hearing about deterministic and reliable networking for 6G radio access networks from Doug Castor.
Long walk. Exercise. Okay, hello everyone. My name is Doug Castor. I think I've had a chance to meet everyone here, but online I'm Doug Castor. I am Vice Chair of the Roadmap Working Group and also have a recently appointed position as of the steering group, Next Year Alliance. Thank you. Okay, so the purpose of my presentation, my talk, is about deterministic, reliable, and resilient networks. And really what I'm hoping we can do today is just talk about those ideas and think about what we can do together, what is the perspective of this towards 6G. And we brought this topic up because there was a workshop at the Beyond 5G International Conference in Tokyo. I know David Young was there. I think 6G Forum was there. I don't know if it was anyone from this group, but the idea, some of the alliances got together and came up with the idea of focusing on 6G resilience for a topic that seems to be not getting enough attention at the ITU and going forward. So, so that was really the motivation of this presentation. And then furthermore, a few weeks ago at the 6G symposium in Oulu, there was a group, which is a subset of that group, that got together and formed a 6G resilience team. And they're still working on defining, what are the, what does this mean, and what is the potential activities that they would do together. But this is led by Amati Latbaaho, if you know who he is, over in Oulu. And I think if some of these topics resonate, we can go back and try to, realign and combine some of the thoughts there. So that's kind of the motivation of what this is about. So I wanted to tee it up with some ideas so you can see the agenda I have there to do so. All right, so I'll just start off with a few definitions. Because these terms, reliability, resilience, and determinism, mean a lot of things to different people. And I think a lot of times when we hear resilience, we think of the supply chain, as JD was focusing on yesterday in his talk, and he's talked a little bit about the ORAN and the supply chain, but really that's not what this presentation is about. This is really about looking at what are some of the other technologies that can provide resilience, reliability, and determinism. So for that, I went into the ITU framework document and looked up some definitions just to ground us on that. So reliability refers to the air interface capability of transmitting and receiving data reliably, successfully, bit error rates, packet error rates. Resilience is that the system needs to correctly operate and sustain natural and man-made disturbances. So this is the ability to keep the system up in the case of those disturbances. And deterministic is really about the guaranteed quality of service and the consistency of user experiences, which is really important as we go into immersive experiences, because we simply can't afford to have changes in quality of services and dropouts, because that would just ruin the immersive experience. I put this slide in here just to kind of compare these topics to what we see from the governments in terms of reliability and resilience. JD spent a lot of time yesterday focusing on this joint announcements was between the United States, Korea, and 7 other countries have talked about these topics in resilience, reliability, and coverage, and you see some of the language there reflected in the governments. But again, I think it goes a lot broader than that. We need to look at some of the technologies. This is not about just the supply chain. There's more to be looked at in these terms. So I also wanted to put some focus on, from the North American perspective, what's the importance of resilience, reliability, and determinism. And I took some examples, and first one in Hawaii, in Maui. Last August, we had a horrible fire, right, which was a North American natural disaster. There's disasters like that all throughout the world, earthquakes, tsunamis. That I think is what maybe prompted some of the discussion in Tokyo. But it's, you know, it's a global problem to be able to deal with this. This is what it looked like in the US. And for over 8 days, we had more than 50% of the cell sites out. And then another example is when it comes to mission critical networking for autonomous driving. North America is the second largest automotive market. You know, we enjoy our commutes. We want them to be, you know, comfortable. We want them to work successfully. So when we see that 10 self-driving cars cause a huge traffic jam because of a wireless outage, that's a problem. So clearly we need more reliability. And the last one is deals with immersive gaming. Right there, it's not maybe a public safety mission critical, but you know, mission for the gamers to make sure that they have a consistent experience. And this is a, you know, a very big market, $330 billion of growth expected by 2030. So a plot that I found in some in a paper showed that gameplay time is you know, goes down when network loss goes up. Fairly obvious, but that's kind of just directly translates to, you know, gameplay is basically the economic value there that's not going to be successful unless we can have reliability in the networks. And then these are some of the other examples, because in Next Alliance we've done a lot of white papers on use cases. Keedong has led our applications working group, and you know, I combed through a lot of the documents to get some more examples. You know, public safety, we need to have, you know, we need to have coverage enhancements. We need to make sure we have continuity when the networks goes down. Multi-sensory immersive experiences, that consistency is necessary for realism. You need to have precisioning as well, and ultra low latency. Autonomous driving, as I just spoke about, we need that ultra low latency, seamless coverage. The last presentation on NTN, I think, is another way that we can provide resilience and reliability through that extra, you know, extra way of connecting our autonomous driving. And then robotics needs service continuity. So for the next few slides, I just want to go through a few examples of technology directions, which I think we could consider. And these are just examples. I'd be interested to hear other thoughts as well. The first one is, you know, multi-hop and mesh networking. This is really important for reliability and resilience of our systems, because you know, we need to be able to withstand the intentional and unintentional attacks or faults. You see some of the technologies and some of the topologies listed here on the figure on the right. You know, we can have multi-hop relays for automotive or drone systems. Urban air mobility systems could certainly need more reliability and more resilience in the system. And that's where if we have the multi-hop and mesh networking, that can help add to that. Cooperative networks, UE aggregation, and you can see some of the other examples, and the NTN and satellite is tied in there as well. So some of the challenges we need to address here is, you know, how do you deal with the lower latency on multi-hop systems, because each hop adds additional latency, so that needs to be looked at. You have the opportunity for multi-link adaptation and resource management, because you want to make sure that you are efficiently using your resources, and if you have multi-hop, that becomes a joint problem that needs to be addressed. Discovery, formation, load balancing, synchronization are all other examples of challenges that need to be looked at in order to be successful in multi-hop mesh network. Okay, another one which is a technology which perhaps doesn't get talked about as often as it should is flexible packet coding. And I'll just kind of skip to the bottom to explain what that is. So today, you know, we think of the inner coding as at the physical layer. You have color codes and LDC codes, but with flexible packet coding, we focus on adding an outer code to that. The simplest form that we have in 3GPP today of that is the packet duplication, which is at the PDCP layer, which does duplication for the URLC case to support the lower latency. But the opportunity here is to expand that and go beyond packet duplication to put up, you know, a flex packet code, which will allow us to have more flexibility across the latency, throughput, and reliability trade-offs, right? And that's really important when we look at all these new use cases such as immersive XR, automotive safety, all of these use cases that are demanding high data rate and low latency at the same time can be addressed better if we have more flexibility. So the challenges here are, looking at understanding these diverse quality of service requirements, and also looking at how do we continue to decrease the latency by adding the linear packet code. The other thing I'll just add on this is that when we get the most benefit out of this when we look at how we can combine this with the diversity at the physical layer. When I say that, diversity through multi-band aggregation, multi-band network coding, diversity through mesh networking, diversity through multi-point connectivity. You combine those two together, you get the most benefit with flexible packet coding. Okay, and then the last technology, which I'll put a spotlight on, is distributed compute and communications. And this is really important from a reliability point of view, because we want to make sure that we have the computing resources available when we need them and where we need them. And then today with 5G, we have cloud computing and we have computing up to the edge of the network. But with 6G, we'd be looking to bring that computing fabric all the way to the UE. So we have this wide area computing fabric that goes from the cloud to the UE. And that provides more opportunity for applications to reach out to computing that is closer to it, or from sharing computing resources across devices, across your smartphone to your wearable, for instance. And that additional capability adds to the reliability of getting access to the computing needs. So that's how I tie that into resilience and reliability. So this helps also with offloading network traffic, and that's another advantage of this. The key challenge here is how do we manage the compute and communication resources together? I mean, that's really what edge computing, distributed computing is about, because if you want to have mobile computing, you need to have both the availability of the computing resources and the communication resources together. One's not good without the other, and that's the key challenge, is that joint management. Just go on to the next slide then. So just in summary, I wanted to tie together those three ideas for research directions versus the requirement APIs that we'd be looking at in terms of reliability, resilience, and determinism. And I won't go through each of these, but just to put a spotlight on the flexible packet coding, for instance. It's, here it helps with reliability because that additional outer code layer adds to reliability without the latency impacts, right? Flexible coding packet coding adds to resilience because you can add this coding over multi-band RAN aggregation, and it helps with determinism because we can have more flexibility to lower the latency targets by reducing the need for retransmissions. And that's really important for the quality of experience that we need in things like immersive communications and autonomous driving. So just my last slide. In conclusion, determinism, reliability, resilience in the 6G radio access networks are essential for a wide range of use cases, from mission critical to entertainment. And reliability and resilience is not just about Open RAN. You see so much focus on Open RAN, and it's certainly important because it helps with the supply chain resiliency, but there's a lot of other metrics and KPIs that we want to look at and tie that in with the resilience and reliability. So I left with some questions there. Which are the most critical to address in the first phase of 6G, and what may be missing from this discussion?
Thank you, Doug. Do we have any questions?
I'm very interested with this, and you suggested some flexible packet coding. So in there, I just want to check with this, your outcode layer is still below this maybe there to functionality, or otherwise there's some issue you're surpassed with this approach to PDC, right? I'm not pretty sure about this your suggestion regarding some outcode application. Would
say the position you mean in the,
Yeah, in the most of case, in the hot process definition, and then the such procedure operation is operated within some RLC separator. So, but still, your suggested output layer is located just over some RLC layer. I'm not pretty sure about.
if I understand your question, you're asking where this flexible packet coding should be implemented, right? Relative to HFC.
In your suggested figure, in your functions of positions within a PDCP subray, right?
So two comments on that. One is it doesn't have to be in PDCP, right? You can, I think this should be studied. Where is the right place to put the outer code? But the value of the outer code here in flexible packet coding versus HARC, as you mentioned, HARC is a backward error correction code, right? So it's increasing latency, right? Whereas if you do the forward, I think a flexible packet coding is a forward error correction, which can reduce latency, right? So that's one of the advantages of going flexible packet coding versus HARC.
Any other questions? All right, if not, thank you, Doug.
Thank you.
All right, and next we will be discussing radio technologies for new 6G applications by Jayden. Thank you.
Okay, right now it's 1:56, and I'm a little bit nervous beginning of my presentation in the next 15 minutes. Okay, getting early. So many times we see this such a 6G usage scenarios and capabilities and standardization timeline and stuff. Simply skip some such contents. There might be some lots of the 6G brand new application proposal involved, but in my presentation we are a little bit more focused on this our own business, our company's own business focus, which is surely empowered by the 6G wireless connectivity. The first one is a hyper immersive multimedia. The LG just now happens to put some great business unit for the high quality video display, such as some OLED TV. And then recently, we just now have a great R&D investment on the XR devices and the future-proof metaverse device access. And such a way is very tied with our company's big vision on some connection and extension of a user experience and the personal living spaces. So in there, we can put one 6G technology enable as some hyper immersive video communication. And next one is a smart industry solution. We can say about this during this 2 years ago, we still have some really developed and deployed some customized full solution of private 5G from our in-house smart factory to other places, other vendors' factories or public sites, and in there, and we also have a very great the robot development business is also delivered to some. For example, we will provide some logistics robot in our smart factory, and a great job. And then recently we have a bunch of experience from such a smart factory operation. So my suggestion is connected AI and robot everywhere is the next our enabler keyword. And the final one is the future mobility solution, and which is enabled some still have a some foot on hold in the automated driving, but definitely we can have some great business unit on the global #1 smart telematics business in our company. So we will strive for having some great leadership on some automated driving, and further extended to the advanced air mobility side. We also have extend our expertise for some such an air mobility situation. So in there, there's our advanced some 6G technology enabled is the aerial 3D coverage support. Yes, so well matched with some provided 6 usage scenario of IT 2030. Is defined in the IT law. So many times during the yesterday discussion and also today, and so many times we have some spectrum stuffs, and we really communicated more than 2 years with some other partners. And the one thing to be clarified is a huge amount of 6G spectrum that is already provided from the WRC 23, but only limited spectrum can be utilized, mainly due to the some neighbor band crossing interference issues or overactive use of different purpose implementation. For an example, 7.15 to the 8.4, there is some we just now have a take into account the military satellite use on the second band. So in that sense, in the WGS just now having some satellite downlink in the 2.25, 7.25 to the 7.75 as some downlink. So it will be some, the most of our unmanned battle vehicle in the US side is the US military is just now operated by such a down. So I'm not pretty sure about this, how to use such a spectrum can be still overlap with military purpose. We're gonna have some great effort on some coexistence study in the future. And the system architecture perspective, today morning we have a great discussion with the Nokia, and the smooth migration and fulfilled 5G, 6G orchestration is still getting assessed from some industry side, well, and also substantial level of site reusability for 5G radio node can give us some great attraction in 6G deployment. Standalone mode is assessed, but also non-standalone mode can be some meaningful in such a migration and orchestration. You start getting the simultaneous support in the initial phase of the 6G standardization is required. Yes, taking some achievable bandwidth. We just now have getting consensus on the few hundred, 400 megahertz or little more per operator aggregate bandwidth is expected. So still spectral efficiency is still need to be enhanced, and the radio coverage enhancement is still needed. And the AI application considered as some expanded application, and the integrated sensing and communication is very important. The advanced air mobility has to be supported at the initial phase, and then the rate of organization is always favorable. So one thing to be clarified is regarding the extreme MIMO, in the next presentation, Amitabha will provide some sophisticated technical stuff, but still we are main focus on the extreme MIMO is radio coverage enhancement and MU capacity increase. So current AI and ML based CSI framework is also closely tied with such an effective overhead reduction of an extended number of antenna ports. And also, one thing to be clarified is just a user-specific beamforming provided by the extreme MIMO is also needed to be equivalent with some synchronization coverage and data control coverage is as well. So how to expand some effectively in the synchronized coverage and non-data associated control coverage is also getting some valuable point. And then regarding such a situation in the potential spectrum candidate, range of physical array aperture is carefully viewed to be considered into some reasonable case of antenna port number and the types of measurement reporting is very valuable from the one-shot standardization in the initial phase. It's very, very good. Big lesson from the 5G. Advanced difference, we can simply think about some G-node B in band through difference capability is supported in this initial phase of 6G, and further extended can be extended to the U side according to some demands and technical maturity, and the flexible resource utilization efficiency is somewhat our main focus, but still throughput increase can be expected. Anyhow, such advanced duplex should provide some very synergetic relationship with the extreme MIMO. So we can still have some totally different approach on from the 5G and 4G LTE stuff. We are still now have investigating now. And other applications such as integrated communication and sensing, the RIS and the vehicle communication case is need to be considered. AI framework. Most of the stuff is mentioned in the Qualcomm's presentation. Yes, we just now have a big boundary from the 5G advanced. In the 6G, we're gonna have some try to getting some E2E system across the layer. The AI machine learning can operate it still up to some on-device AI side, and the near real-time update is important. And we can still take into account some running algorithm can be extended to some generative AI side, which is mainly focused on some mid-term, long-term approach of the semantic communication, and still have some very aligned view with the Ting-Bang's comment. Testability is a very, very big hurdle on the successful application and the AI machine learning application of air interface. Integrated sensing and communication. One thing to be clarified, the reasonable range of resolution has to be justified in the case of a spectrum shared ISAC operation. So when we directly applying this theoretical approach on the Kramer bomb, we still have some, even with some 400 megahertz, we still have some few tens of centimeters resolution can be achieved. So it is a big expense when we apply some ISAC on the communication band. So we also have a great approach on the simultaneously use of a communication signal for sensing especially on the network side sensing, is a great value, but still have investigating regarding the some provided resolution. It's somebody. RIS, wanting to be clarified, yes, from full passive RIS to the some active RIS using the some NCR controllability. We can have anyway, it can be provide some signal quality enhancement in 6G deployment and the big issue. One thing to be clarified is the proliferate use of a multi-layer Lowy glass. In there, the some O2I penetration loss is very, very severe. So the over the some 40 dB penetration loss is driven from the some multi-layer Lowy glass. So we still have some well patternized passive or semi-active surface design. We are able getting the some value from the some. Originally, we have some great collaboration with the car OEM. How premium level of smart car is applied some such multi-layer Lowy glass in the car window. So if you are in the vehicle, you cannot communicate with this some other genome signal is not penetrate into the superbly. So this is somewhat great issue. So we're gonna have some deep investigation regarding the such some aspects, and then we're gonna have some great solution in the future. Rest page, I'm just now getting hurry. And the 60-bit communication, wanted to be clarified in the when it comes to the PC5 interface, there is no need of a PC5 interface design in the initial 60 standardization. Because most of the identified automated use cases are fully supported by the some 5G advanced PC5 connectivity. So instead, we just now have a new enhancement features, which is driven in the 6G, can be jointly integrated with some considered further, primarily based on the some V10 perspective. For example, the ISEC, NTN, and digital twinning, and the immersive multimedia experience to the passengers and driver can be assessed. And our company is proposed to the 5G of most of aspects. And next week, 5G AA will capture the most of stuff in the SA workshop. So one thing to be clarified is vehicle application layer still have some very valuable situation awareness information. So if it is successfully delivered to the some access layer, it's going to be a very helpful for the some AI ML based some V10 communication as well. And when it comes to the AAM, as I assessed it before, it should be supportive in this initial phase of 6G. So variation methodology and such as some physical study can be started from the initial phase. This is our company's. That's all my presentation.
Thank you. Do we have questions?
I think you mentioned some synergy between MIMO and embedded full flex. Can you give some details about that?
Yeah. And we just now have thinking about this very significant level of antenna domain isolation technique can facilitate some synergetic integration with the extreme MIMO. So we are now trying to design some very great performance, some aperture-based isolation solution. It is a full passive type solution is just now really studied and designed. So it should be somewhat enabled.
Okay, I can just speak loud. Maybe
well, for the people online, let me
All right.
too.
Oh, okay. Focus online. Yeah. So I think I have the same question for JU offline. I asked for the AAM that you're showing here or UAM. What amount the fraction of traffic that's geared towards these airplanes or these drones that air taxis will probably be very small compared to the traffic we carry on the phone. Well, why is this a priority, and why should we spend energy on this?
Today morning, we just now have some the UAM service from some Edge Plus. So in there, some anyhow, some vertical industry case is not so satisfied with some mobile traffic increases. Anyway, it is some UAM. There might be some successful terrestrial network infra support for some the AAM communication is somewhat very necessary for some guaranteeing the some safe management and control on some AAM. So in this sense, and we just now have some great observation in some upward the radio propagation. There's some how can we utilize some such the up tilting angle can be provided in the backlobe side.
Yeah, so that I think that's a part that we also talk offline, that having a separate network opportunity just to serve this seem to be a pretty expensive investment to make, right? If you have to install separate set of hardware and base station. Instead, we know for massive MIMO array, right? Actually, most of them are steerable in elevation. We have many dimensions in elevation. And it has very sharp beam. It's very different from the mechanical tuning, right? At 800 macros, which was what I heard offline. So having the same antenna array, AAS system, right, and having separate vertical beams might be. Maybe we should consider that. I'm saying single network supporting both services, just deploying a separate network for this, which has very little traffic, seem to be, at least from my perspective, seem to be a little bit expensive.
I think that we also have some rather so soon the situation in the LTE advanced situation. In there, there's some metropolitan areas of the low rising GNODB antenna can still have some the higher floor support. In there, there's some full dimension MIMO is some raised on the some degree of freedom in such a case. Even in the case, we have some considerable level of evaluation methodology is set. So whatever we can use, and it to be some very helpful information. So in that sense, and we just now start with some such the evaluation methodology consideration is some now we are pointed out in this sense. Yeah. I also have in the technology application perspective, we can judge and decide that how can we support. It will need to be further investigated in this PPT.
Great, thank you very much. And the MIMO discussion is a great lead now into the extreme MIMO presentation from Amitabh. Thank you.
Okay, good afternoon, everybody. So I think I'll not tell anything new here. So, but it is extreme MIMO technologies for future wireless communications. So all of you know I'm very familiar with MIMO. So next slide. So this is the outline. I'll have an overview. You all know this, release 18 and release 19, what are the features, I'll not go through in detail. Then I'll go to what is extreme MIMO, briefly discuss WRC23 outcome here. And although I have not put in all the slides for WRC23 outcome, I'll briefly discuss what are the issues with 7 to 8.4 gigahertz time. Then I have some simulation results that what will extreme MIMO bring you, right? And then we had a white paper, Tinfang white paper on what are the research direction, and you talked about it, race and cooperative MIMO and so on and so forth. I'll briefly discuss that summary. But the main focus of this presentation, I will say, is the what can extreme MIMO in the midband bring you, right? So why you want to go to 6G radio? So there are two possibilities, two areas, performance and scalability and optimization. I will discuss only the performance part. We want very high data rates to support all the fantastic applications like holodeck. Everybody will have holodeck going forward. Of course, uplink is a problem, right? Because uplink, you are limited by the power of the UE, 23 dBm, 26 dBm. So the only way you can improve the uplink is to put more number of antennas. CPs, you can have more power and you can have a better uplink. Then the other point is the CSPs, at least in the USA, they don't want densification. They want to use the same macro level grid. And without densification, you can't use millimeter wave. So midband is the only possibility, right? And to do that, there are a couple of techniques everybody uses, and we will use the technique to use the same macro level grid. We'll not talk about energy efficient networks and these lean intelligent efficiency usage of diverse spectrum sharing, AI, ML enabled radio. Tinfang already talked about that. So we'll not talk about all these aspects. So main thing we'll talk about how to achieve very high data rates, a little bit how to enhance uplink, and how to use the same macro cell grid for this 7 to 15 gigahertz. So this, what is the definition of massive MIMO? Now we have massive MIMO, then we are going to extreme MIMO, right? So if the number of controllable antenna elements is greater than 8, we call it much greater than 8, we call it a massive MIMO system. I have to come up with a definition of extreme MIMO, where the number of controllable antenna elements is much greater than 64 probably, I don't know. But, so that is the definition. And the goal is to enhance the coverage, enhance the capacity. That's what we have been using. And the evolution of MIMO has always been greater number of antenna elements, larger arrays, higher carrier frequencies, and higher bandwidths. Those are the three things. And so in release 15 NR, we are very excited of millimeter wave. Hey, we are getting all this huge bandwidth, but the issue is with penetration loss and the path loss and the use of densification. So it didn't pan out, right? So people in the US, the operators still make fun of massive MIMO or fun of millimeter wave, saying that what a mistake it was to go with millimeter wave. But I am a believer of millimeter wave. I have been proposing millimeter wave since its inception. So Then, but if you look at the massive MIMO, the progress has been incremental. And every release, as you will see, will have some MIMO capabilities, massive MIMO capabilities, right? And what we are doing in every release, we are increasing the array sizes, which is improving the spectral efficiency and coverage. If you increase the array sizes, you will have better feedback schemes so that you have less overhead. And then we are using all these COM kind of techniques to improve spectral efficiency. So that is the massive MIMO. Going forward is that, so in 5G NR, we went with a beam-based air interface. Everybody knows about it. What is a beam-based air interface? Will not explain, but we have SU MIMO, single user MIMO up to 8 transmission layers. MU MIMO is the main, multi-user MIMO is the main key technique for further improving the spectral efficiency. For the beam management, I'll not explain. You have these 3 schemes, right? So you have these fat beams called P1, the UE searches for the fat beams. Then you have beam refinement. A fat beam consists of multiple narrow beams, and then you have UE beam refinement. Generally, we go with P1 and P2. And then we have CSI acquisition. Currently, there are 2 types of feedback. Type 1 feedback, the basic idea is type 1 feedback is less number of bits. Type 2 feedback is more number of bits. With more number of feedback bits, you have better performance on the downlink, but you suffer on the uplink, right? Because you take away the spectral efficiency. And then there's this multi-TRP, right? So we had this COM in LTE, COM, cooperative multi-point combination, both for downlink and uplink. It was never implemented by the operators. Why? Because the gain was not that huge. So there's spectral efficiency again. If I remember, the simulation is all of 10% for the downlink. So now we are bringing back multi-TRP in terms of non-coherent joint transmission and coherent joint transmission. So the next is the 3GPP release 18 MIMO evolution. As I said, every release has MIMO. So what are the features of release 18? So enhancement to streamline beam management signaling, improving downlink and uplink coverage and capacity performance, and coherent JT and uplink gate transmit support. So these are the main features for release 18. Now, how much gain you will get, I don't know. People have done simulations, but and have a lot of IPRs in this. But what is the actual gain? What the operators will implement, whether we will have UEs to support all this, I don't know. But these are release 18 features. Release 19, again, we have a MIMO system. There is beam management enhancements. There is CSI enhancements where support of 128 CSI ports for FR1. Uplink enhancements is there. And then asymmetric downlink STRP uplink multiple transmission ports. Again, so every release has MIMO enhancement. This will have MIMO enhancements. I don't know how much all these MIMO enhancements will bring to the coverage capacity, but it will bring improvement. So the WRC 23 outcome, everybody knows about it. So this shows the whole world map. And if you read on this, what are the bands which are more interesting? For US, this 7.125 to 8.4 gigahertz is very interesting. or we are focusing our energy into this band. Now, if you look at this 12.7 gigahertz band, this 12.7 gigahertz band is outside the WRC process. It has been allocated by FCC for mobile use or study for mobile use. So there is an NPRM already out, but in WRC, the 14 gigahertz band was discussed for WRC 27. But when you talk to some of the US operators, they say this high bands is like millimeter wave. So currently we are not interested. But maybe they will be interested because if you look at the 7.125 to 8.54 gigahertz band, it is a shared band. And if you look at this, there are fixed services in the band which will occupy the whole band. And if there are fixed services, you have to repack it so that they occupy the upper and lower band. So you have to move those services. There will be bands in this 7.125 to 8.4 gigahertz. There will be bands shared with space terminals. And there is issues with coexistence. Then there will be bands with ground-based and maritime terminals. And we need to have a sharing mechanism. So there are three kinds of incumbents in these bands. So one is the fixed service. We'll handle them by moving them to the edge of the band. Then there is band share with ground-based and maritime terminals. We can handle them by having an effective sharing mechanism like CBRS has, but it is complicated. And then there will be band shared with space terminal. So this band is not fully for exclusive use. It is crowded with incumbents in there. Okay, so this, all you know, is the wedding cake. Is the wedding cake. So we are, and this was discussed in one of the presentations. So I'll not go through it. You'll see 90 to 250 gigahertz is for sensing and short range. So there are comments. Why not the other bands can be used for sensing? Of course, it can be used for sensing. Therefore, I added this. Sensing technology can be applied to all frequency ranges, but the accuracy may not be that. And our main interest is in the new 6G, 6 to 24 gigahertz band. Now, so you know about the aperture story, that as you go higher in band, your path loss and penetration loss increases proportionally, but your antenna size grows smaller. So the point of the right-hand portion is that you can, in the same form factor or the same aperture, you can accommodate more number of antenna elements that overcome the path loss. Right? So how can extreme MIMO gains be achieved with acceptable complexity? So one of the things you have to realize this, you know, the EIRP, right? So for the C-band, the EIRP was 82 dBm per 100 megahertz. Now for these bands, the 12.7 to 13.25, the original FCC definition was 75 dBm. With that EIRP, you will not get any coverage. It will be zero cell edge deterrent if we use the same macro grid. So our proposal is to increase the EIRP. Now, if you increase the EIRP, what problem will you have? You will have problem with the EMF compliance distance. So you have to increase the EIRP so that your EMF compliant distance, you don't have to have a huge EMF distance, because otherwise you can't operate within a certain range of the base station, right? So you have to satisfy this criteria. So what we found out, we did a lot of simulation. 85 dBm per 100 megahertz is what the EIRP we are proposing for the 7.125 to 8.4 gigahertz range, and also for the 13 gigahertz range, so that we have a respectable sellage and user experience. You see. So that's the proposal, what we are doing. Now, we did a lot of simulations, and so these are the assumptions we used. 7 gigahertz, we used 8 Omnis, and what we found out, we can use a 500 millimeter urban grid with 13 gigahertz RX Omni UEs. We can reuse the 350 meter urban grid, so you have to densify a bit. With 13 gigahertz 8 RX Omni, we have degraded sellage for 500 meter. So if you compare 7 gigahertz to 3.5 gigahertz, now these are the assumptions. So this is the C band, right? 3.5 gigahertz is the C band. The EIRP was 82 dBm per 100 megahertz. We have 4 RX Omni and CP is 4 RX direction antennas. When we did this simulation for 7 and 13, we use 85 dBm per 100 megahertz. We use 8 RX Omni and CP, we used 8 RX directional antennas. Now this is with 500 meter ISD, we get in spectral efficiency, sellage spectral efficiency, 1.2x with UE, 1.7x with CP, and 13 gigahertz. It is, you can see, we get a degraded performance. Now, when it goes to CPE, of course, it improves, right? With 350 meter ISD, it improves. Now, so these are the spectral efficiency. But if you get 400 megahertz bandwidth, so if you are getting some amount of sellage, say 500 megabits, due to this increase in bandwidth, you get 4 times that value, right? Plus the spectral efficiency improvement of 1.7. That's what you get. Now, this band, so this assumes the band is for exclusive use. So there is no other incumbents in this band. Now with incumbents and with sharing mechanisms, these numbers may not hold. So this is what we have, and this shows the detailed sellage spectral efficiency and sellage throughput numbers onto the right side, with 350 meter IST and 500 meter IST. So the bottom, so the upshot of this slide is that if in urban areas, if we use 500 meter IST, the 7 gigahertz band will still give you advantage over C band with 1024 antenna elements. They use 250, 128 or 64 antenna elements. We are using 1024 antenna elements. Sorry about that. Same thing with uplink. You see. So 3.5, 7, and 13 gigahertz. You can see the CP throughput and UE throughput. So these are the numbers you are getting with UE device. And these are the numbers you are getting. Still 7 gigahertz, you are getting an advantage over 350 meter IST. And this assumes 5G benchmark was 64 TRX, 256 antenna elements, and the benchmark for 6G was 1024 antenna element with 256 transceivers. So, so what we are showing that if you increase the number of transceiver antenna elements, you are still getting advantage compared to C band with respect to spectral efficiency. And on top of it, add the bandwidth of additional 4 times the bandwidth. Next. Okay, so this is, you look at our paper, the phase 1 paper we did, and we talked about reflecting intelligent surface. And I believe that reflecting intelligent surface can give you really good coverage for millimeter wave system, you see. So you place this wrist in locations and you get reflections and you can improve the coverage. You can bring signals from indoor to outdoor and outdoor to indoor by providing wrist in the buildings. The massively distributed MIMO, MIMO, or we can call it, it is a complex system, which we are already doing in release 18 and 19. This will improve the performance. How much, I don't know. Then we have terahertz and sub-terahertz. Now, once you say sub-terahertz, the operators really get scared. The millimeter wave didn't work, so why you are proposing sub-terahertz now? So this will never happen in the near term. Long term, of course, it will happen, but not in the near term. So finally, I have my conclusion. So massive MIMO will always be there. Every release will have massive MIMO. There will be incremental improvement to massive MIMO in every releases. Now in 7 to 15 gigahertz, there's a 2 gigahertz of spectrum for exclusive or shared use in the 7 to 15 gigahertz range, and up to 700 megahertz of spectrum in the upper 6 gigahertz band. The performance I showed you is also applicable to upper 6 gigahertz band. Now, this upper 6 gigahertz band is not applicable in the US because it is a unlicensed band. As you go higher in frequency, you have to have path loss and penetration loss compensation. And you do that by achieving the known techniques. You keep the aperture size the same and increase the number of antenna elements and number of transceivers. You increase the EIRP. So these are the 2 techniques you use to get the coverage improvement. And what I claim that you can keep using the same macro grid, provided you go to 1024 antenna elements with 85 dBm per 100 megahertz EIRP. And this details what kind of improvement we'll get in the mean throughput. The one I showed you was edge throughput. These are the mean throughputs. And we discussed also what are the other future direction in terms of race, you want some massively distributed massive MIMO, and so on and so forth. So that ends my presentation. But this gives you a numerical values to the performance thing.
We are over time, but we'll take away a little from our coffee break. So let me start first. You're closer to me, so
just a very quick question clarification, and then the very valuable point that the 5G radio rules position is still reusable for some 6G. In there, there's some extreme MIMO provide traffic. And when in your simulation, in there, we can understand there's some intersite distance of 500 meters of very low model. But when it comes to the 350 meters, I still have some getting meaningful in this real build deployment.
In some very dense urban areas, there will be 350 meter. I've heard in Tokyo and all, there are around 350 meter ISDs or 300 meter ISD. But for urban, probably, but the US deployments are 500 meters, so sometimes up to 5 kilometers.
Yeah, it's I think we share. I agree with what Amitabha showed, 99%. And there's the last 1% is a numerical result. I think it's really encouraging to see all of you have seen that at the 7 gigahertz, right, with the same antenna size, we can even boost the spectral efficiency. Even the edge uplink can match the 3.5. That's super encouraging.
More higher antenna size.
Right. So yeah, more digital chains. But the 13 gigahertz one, you also use the same ERP, which means it's a quarter size of the panel, right? Of course, you can argue that for in the exposure, you want to keep the 85 dBm exposure. But because it's more directional, actually we are arguing for FCC to further relax it. So actually allow the same panel size instead of quarter panel size compared to C-band. If you allow 4K elements, increase the ERP. What we saw is it actually matches what you are for 7 gigahertz as well. Just one caveat over there.
Yeah, absolutely. So 4096 antenna element, is the technology there to implement it? If it is there, why not?
Any other questions? All right, thank you, Amitabh.
Thank you.
All right, and now we will hear from Young about emerging wireless technologies for 6G cellular systems.
Hello everyone, I'm Young Nam from Samsung Research America. Today I'm representing Samsung Korea for 6G Forum. I'm going to talk about Samsung's view on 6G. So where is MIMO? Okay, from our 5G deployment experience, we got mixed reviews from our customers. Korean customers in general, negative. We had actually very successful 4G optimization there, and 5G came a bit too late, and it took some time to fully optimize those 5G. So we got comments like 4G is good enough to watch videos. 5G connection drains the battery faster. But in United States, relatively 4G optimization was not done as thoroughly as Korea. So we got better review. So people were happier with 5G than 4G. So this is where we are. And we try to understand where we want to go from here. So there are two things. One is technology, and the other is use case. So basically, if we just stick to this like a cell phone use case, watching video, having video conferencing, maybe there are so many things we can do. That's one thing. And technology-wise, we want to understand where are opportunities for us to satisfy our customers better in 6G. Okay, so in network implementation point of view, we are seeing network is going towards softwareization, virtualization already. So that's happening in 5G. And it's actually deviating from traditional deployment of hardware centric, where we optimize individual network function in hardware, and we try to deploy them. That's actually working very good in limited sense, but it's very difficult to upgrade. So basically, to deal with actually technology innovations we are seeing in recent phases, especially with AI, ML, this softwareization, virtualization becomes even more important in 6G. So basically, we envision in 6G we are gonna have some merge of this software and AI together. And we believe this AI will be available in all the network functions, including this radio unit physical layer as well. So towards that, we probably need to have this unified AI-native orchestration as ORAN and 3GPP are envisioning. Then about use case. So still, although there are many new use cases are being discussed in industry, we believe that this traditional cell phone use case will be still very important. So that's our starting point. But recently we have all those hypes and a lot of interesting demos from different vendors on this generative network, generative AI, and robots. So those are going to be like a future use cases in 6G. Right now, we are also seeing like extended use cases of 5G, like a satellite to phone, fixed wireless access, enterprise market, and so on. So actually, I would like to emphasize one use case here that's about fixed wireless. At least in United States, we are seeing this fixed wireless is consuming a lot of data rate, and some operators are already kind of reaching up their capacity limit in C-band, FR1, and they are kind of considering use of some other carrier frequency like FR2. So I think at least at the moment, so if we think of capacity crunch, the most promising use cases seem to be FWA, but maybe in the future we can think of other use cases as well. Then about how we shape 6G. So in the past, we were focusing a lot on this spider diagram. We thought of a few KPIs, and we tried to advertise. We got like a multiple X beyond what we used to achieve with a certain G. So probably we will have to do this again, but I think what matters is the customer satisfaction rather than we advertise a certain X performance gain. So basically that should be our focus. And we already heard a lot about like different technology aspects in this week's discussion. So in Samsung point of view, we are focusing on mainly 4 things: AI native, energy efficiency, coverage, and secure and resilient network. So for AI is everywhere, and wireless industry should not be an exception. And the use cases of AI, we are seeing that they can be used in like all the network layers, including layer 1, layer 2. We already know that AI is very good at finding missing information, utilizing some trial. So basically, trial is going to be pre-trained neural network. So having that analogy in mind, so basically we can use AI for channel prediction with some limited CSI we obtained from like UE and some channel training at the base station side. That could be like a first use cases we can think of, and we can also do like a pre-coding scheduling with the AI. And currently, we are mainly utilizing AI for like a self-organizing network, and that will continue. And telco LLM, yeah, we can obviously imagine some simple use case of like replacing some user service for customer service for network deployment. But we can also think of some lower layer telco LLM as well. Then we would like to focus on just one simple, actually not simple, one core important use case of AI or network. So traditionally, we had one solution deployed across all the cells in the network. And we had some limited possibility of parameter optimization across all these different cells. So there was like a typical deployment in current 5G network, but with AI native architecture and AI orchestration, we could have all the network functions equipped with AI modules pre-trained before deployment. So that will include actually like a layer 1 modem, layer 2 scheduler, and so on. And we will probably start with the pre-trained model, but once we have like a deployment, an individual AI module will continue run after deployment, and they will actually individually optimize their network performance, which we call a million solutions for a million base station. They will be realizable. And toward this vision, we would like to work together with other companies, try to make like overall network performance better and cost down as well. Then about energy efficiency, we know that there are many other like higher layer technologies like cell on-off based upon traffic demand. Also, this scheduler level optimization like dynamic micro sleep and so on. So, but in addition to those technologies, we can actually do further improvement in physical layer as well. So we are just giving two examples of physical layer energy efficient methodologies. One is about envelope tracking. So as you know, this OFDM signal in time domain that's fluctuating in amplitude. And we are kind of wasting a lot of energy in those time samples with like a smaller amplitude. So if we can detect fast enough over these envelopes, then we can adapt this DC power, and we can reduce the power consumption accordingly. And we have done some preliminary evaluation, and we have seen we can get like up to 30% power consumption reduction in high data loading scenario. And this is actually applicable on top of like all those upper layer technologies as well. So this seems to be one promising direction. And another is this coding modulation. So in 3GPP so far, we have never considered this circular constellation yet. But in other standards like multimedia, they are already adopting this circular constellation. So probably we can also think about this kind of possibility in 6G. From information theory, we know that actually this circular constellation will achieve a higher energy efficiency and higher spectral efficiency. And about spectrum, we heard a lot of interesting discussion yesterday, so I'm not going to cover a lot of details. But in high level, we have FR1, FR2, FR3, and FR1, FR2 are already available. FR3, I mean, WRC23 gave us some bandwidth, but in order for market to adopt, they will take some time. So basically, maybe we start with FR1, FR2 optimization because they are already available, and FR2 is underutilized. So we want to find a way to better utilize FR2. That's our company's priority. And FR3, yeah, that's kind of the future, and we need to actually be able to use FR3. And at the moment, this capacity killer use case that has not been very well identified. So probably we can start thinking of FWA first, and then we will gradually move on to other uses of spectrum. And about coverage. So coverage is mainly about like how many users can achieve certain desired data rate for uplink and downlink. So that's the coverage definition we are seeing from like 3GPP, TR, and so on. I think based on that assessment, so we are seeing actually this, especially FR2 coverage is really limited. And I think the main root cause of FR2 coverage being limited was because we were thinking FR2 is like a small cell. When we first deployed our FR2 in 5G, in a sense, there was kind of mistake. So, I mean, in terms of 5G standard, I don't think 5G standard is limiting us to have a capacity. But in terms of implementation and deployment, we actually started with a small cell. So we would like to revisit this overall FR2 technology and deployment, and we try to improve FR2 coverage and capacity. So for example, currently most of the companies EIRP is not reaching FCC EIRP. That's probably the first thing we need to resolve. And then there are other things we can do. For example, we are introducing one technology here that's called joint phase time array. So we didn't show a lot of details here, but that's about adding one time delay component to individual phase shifters we have in analog debugging. Okay. So by having these extra degrees of freedom provided by those extra delay components, we could form frequency selective multiple beams utilizing just a single TRX. So by having this FDM frequency selective beams, we could allow multiple users in different directions and simultaneously receive and transmit. And this will actually help, especially for uplink. So because users will have a more transmission opportunity with that. And considering that we have typically the wireless base station systems are limited by uplink. If we have an uplink capacity improvement methodology, then we actually improve uplink coverage as well. So basically, we believe that's like one promising technology for 6G and even maybe 5G advanced as well. And FR1, we will probably continue to evolve like a massive MIMO and distributed MIMO. Distributed MIMO is more like a comp in my take. Okay, and FR3, Amitabha already covered very well, so I'm not gonna say much. FR3 is kind of providing us a very interesting trade-off between coverage and capacity. And capacity-wise, yeah, we have seen like a similar results as Amitabha have shown in our internal evaluation. Coverage, yeah, we need to probably work more. I mean, including like a standardization effort as well. So, but when FR3 becomes like important, I think there will be some solutions also available for coverage. And finally, we have this multi-connectivity network that's about like satellite. And yeah, that's gonna give us opportunity to solve some digital divide problem as you discussed in the morning. So, and we have this last slide about 3GPP timeline, but probably I don't need to go over this. So that's it. Thank you very much.
Thank you very much. We have some questions.
Thank you for the great presentation of 6G. I have one thing to be clarified. Is you suggested the 6G KPI. In there, there's some actually firing some other campaign of new channel code. If you can strive for there's some realization, change the peak metering method, somewhat easily expected. And when it comes to my point is that when it comes to this reliability perspective, what kind of your view in terms of further improvement on the reliability is still necessary on 6G or not? It's not shown in your spider web. So could you elaborate more about the reliability aspect?
Okay, so I guess reliability is like extension of URLs in 5G. And again, yeah, we would like to see like a killer use case first, then probably we can go a little bit further. So even for 5G URLs, we haven't seen killer use case yet in the market. So, but that's very important. Thank you very much.
Other questions? If not, thank you very much. All right, and next we'll be hearing about driving environmental sustainability priorities in 6G within North America from Bhushan.
Wait. I think you just have to
Just hold the button. Hold the button down.
All right. Can you, yeah, I think you all can hear me.
Yeah.
Well, home stretch, right? So, So I think David saved the best for last. So we'll do our best not to go through. But great. So my name is Bhushan Joshi. I am the chair of the Green-G working group, and I'm proud to serve as the chair along with Ralph Pendley, who is the vice chair, and Gagandeep Bhatti from Nokia. So here's what I'm going to do. I'll try and keep this moving pretty quick. So the agenda is to provide you an overview of the Green-G working group. What is it that we do? What are we focused on driving? We'll give you a quick overview of some of the trends. What are we seeing in the market that's driving us to focus on Green-G and how it's driving our efforts. We'll also give you a quick overview of some of the key white papers that we have published since the group launched, some of the activities that we're up to, and then we'll leave some time at the end for some next steps because I think there's a good opportunity for us to collaborate. So I think I went backward, yeah. Oh, here we go. Perfect. So the mission of the Green-G working group is really, again, to position North America as a leader in environmental sustainability within 6G. And when we talk about environmental sustainability, we're not focused on reducing energy consumption and greenhouse gases only, but also looking at the other environmental impacts, including water consumption, e-waste and things like that. So a little bit of a broader perspective than just energy. Some of the other things we're focused on is, how to drive environmental sustainability within the broader 6G ecosystem. How do we collaborate across the ICT industry, but then also how do you drive collaboration with other industries and identify ways in which they can leverage connectivity to be more sustainable and be more energy efficient. Our goal also is to kind of aggregate information across our industry and present it in a way that it's actionable for people to take some meaningful steps towards achieving some of the global objectives that we have. So I wanted to kind of start with this slide because it's always good to kind of start by scaring people, right? And this is kind of not so much scaring people, but this is the reality that we face. The world is warming. Every year we hear that the year before that was the warmest year since we started keeping history. And it's just undeniable. Human caused carbon emissions are causing climate change. It's not something we can deny. Last year, the United States had 23 extreme weather events and related in $92 billion in economic damage, and lives as well, right? So it's a big impact. So what the U.S. government is doing is that the U.S. government has set a goal to achieve net zero emissions by 2050. I briefly checked to see where South Korea is, and South Korea also has a commitment that I think is aligned with they call it carbon neutrality by 2050, but in that same timeline. Also, the US has a goal to reach 100% carbon pollution-free power by 2035. Again, closely aligned with South Korea. I think their commitment is to have no coal-based power by 2035 and 50% renewable energy. So these are targets that we have to hit. This is where the industry is focused on, and that's what we need to do. So if you look at So these are some of the drivers. These are kind of the three key drivers that are kind of moving us along and propelling our actions. Reaching net zero is what I talked about. I always say there's a climate timeline and there's a technology timeline, right? The climate timeline is dedicated by climate science, which is 50% reduction in greenhouse gas emissions this decade, and then 50% reduction again to reach net zero no later than 2050. So what we have to do is we have to develop technology in a way that it aligns with that climate timeline. 5G was designed to be energy efficient. 6G needs to be designed to be sustainability native. But the good news is that a lot of companies within the ICT sector are setting net zero goals. All the customers here, CSPs here within North America, have targets, what are called science-based targets, to cut their carbon emissions in line with the UN guidance on controlling the worst impacts of climate change. The other aspect that I think we also need to focus on is circular economy. And we kind of talked about that a little bit when we talked about the OCC, the observability, the choice, and the circular economy framework that the Next Year Alliance has proposed. But we use a lot of energy into making these products, and then they get dropped off for e-waste. We need to find ways to recapture, reuse them, because we're going to need more and more of this stuff. So that's a big focus for us. Consumers and investors, when I talk to my child, or I talk to her friends, or some of the younger professionals that work within my company, and anywhere I go, they expect companies to take action on these topics. Investors are another one. BlackRock is an investment firm here in the U.S. $1 trillion I think they manage, and they want to have sustainability within their investment portfolio. The third driver, I think we kind of talked about that a bit. It was really good to see throughout the presentations that you all have made today, energy efficiency and OpEx reduction is a big driver for us. OpEx already is one of the top 5 expense categories for our customers. So, CSPs. So how do we develop 6G in a way that it can be deployed sustainability from an environmental perspective, but then also financially sustainable as well. So that's another big objective. There are financial incentives that are available in the US. We have the Inflation Reduction Act that was passed, provides 30% tax credit on renewable energy investment, which is helping us, because that's one of the key enablers of decarbonization. So really the focus is how do we partner, how do we collaborate and navigate kind of these trends. So the Green Shoe Working Group, since we've been around, we have published a set of white papers. What I'll do is I'll kind of briefly go through each one of them, maybe give you some insights as to what we cover in each one of them. And then, maybe we can have a dialogue, or if you have any questions, happy to answer them. This was the first paper that we launched in 2022. This paper was long. It was kind of high level though, right? So it kind of set the stage of what is it that we're trying to do? Why are we trying to do it? Pretty much kind of defining this for the industry here in North America in terms of what are the actions that we need to take, where all do we need to take action, and what can we do to position the next generation of mobile technology as an enabler for sustainability. So you will see that we covered RAN, core data centers, autonomous systems. We talked about edge computing, fairly broad, but then we went into materials and operational efficiency. So it's a really, really kind of interesting read. But we talked about the fact that we have to look at the entire network. Even though RAN accounts for a large portion of the energy consumption and cost, we are seeing that data centers and core also start using more and more energy. So you cannot just focus on RAN. You have to kind of look at this whole network approach, to energy efficiency within 6G. So that's kind of been the focus. And so our recommendations in here were some discrete technologies and ideas that you could deploy across the network to achieve some of these objectives. I touched on this a bit, but it's more than emissions, right? It's water usage. When we talk about data centers and you talk about generative AI and the use of data centers use a lot of water, other than energy. So what can we do to kind of consider those things, right? Land use is another thing. These data centers take up a lot of land. Where do they need to be deployed? Can they be deployed in a way that the land that is meant for some other use is not diverted from beneficial use, right? So we talk about these things in this white paper. And then the other aspect that I think is really important for us to focus on, which I think we haven't touched quite as much, but I always feel like, our sector is kind of has a superpower, right? We're about 1.5% of the global greenhouse gas emissions, which is not a lot when you think about, 90% of the world carries a phone in their pocket, and uses us on an everyday basis for something, in their life. We found that it has the potential to enable up to 15% reduction in greenhouse gas emissions just within this decade. So that is a big potential. And I think what we need to do is try to do what we can to maximize the use of the networks that have been deployed to enable different sectors to get smart, get more energy efficient. So this is something that we point out in that white paper as well. And really the paper calls for these recommendations, set science-based targets, which is something that most companies are doing, including those here in the room. Invest in supply chains that are sustainable. That's happening now, transitioning to circular economy, and then focus on renewable energy and power consumption, and then maximize the decarbonization potential of ICT. So I think what we did is, once we had this very high level view of where the industry should go, we said we need to kind of get a little bit more granular. So we need to start digging in and trying to find, while there is a North Star that we know reaching net zero, what we found companies needed is operational KPIs. Which specific KPIs can they look at to measure how their sustainability strategies are showing results as they work towards getting to net zero. So this is what this paper talks about. What are the different environmental sustainability KPIs that exist right now? We also introduce environmental sustainability impact categories, because we found that not all impact categories apply equally across the ICT value chain. So we talk about that, and then we talk about how to integrate sustainability as a foundation element within 6G, and then how to measure it as well, right? And then what sort of harmonized set of KPIs could exist, and the fact that we need to do some more research on developing this harmonized set of KPIs. So this is what I was talking about. This is a really interesting graph that's in the white paper, because what it does is that it looks at the different ecosystem components of the 6G ecosystem and says, which ones apply for which ecosystem or for which component. Greenhouse gas emissions, land and biodiversity may not be relevant for land, but it is definitely relevant for data centers. So we also try to go into supply chain and manufacturing, and we cover that in some detail, but not quite a bit. And then this is the areas where we felt we need to have some more work done. How do you allocate energy consumption? Can you develop a consolidated list of KPIs that can be used by the industry? So this is work that we need to keep doing. Where we are working now is, and this is again the current and future KPIs, which is our next white paper now, where we went into more about, so then we went into this. So then we said, let's do a RAN KPI white paper and a data center KPI white paper. So this is the most recent one that we released that looks at KPIs within the RAN, and we introduced this concept of observability, choice, and circular economy, because just having those KPIs are not enough. You kind of need a lens with which to apply them, and which is where the 3 dimensions that we put forward in this white paper come through. So our concept has always been that 5G was energy efficient. It's here for until 2030, which is the first 50% reduction that we need to drive. And then when 6G gets introduced, we're gonna be in this time frame where we need to drive the next 50% reduction. So it needs to be designed to be sustainability native, and that's it's great to see that that's happening with the ITU. So we kind of referenced that in our white paper as well. And then this was presented before, but these are the paradigms that we talk about in the white paper: observability, having the right data set, having the right information, because our position was that you can't manage what you can't measure. So our whole idea has been having the right data available at the right level. So not just looking at energy data at the site level, but at the component level, and how is it available within the different generations, to drive better choice, because that's the second thing that gets enabled. How do you present choice? Subscribers, customers want to be able to choose more sustainable alternatives, and if we don't have observability, we cannot present them choices. So if a provider within the ICT ecosystem wants to use renewable, sustainable data centers, for example, then we have to be able to have the observability to give them that choice. And the final one is circular economy. We kind of talk about it, but I feel like there's a lot more action that the industry needs to do to actually get there, because e-waste is one of the largest growing waste categories. Every year we have more electric equipment that gets phased out and not recovered or beneficially reused. So that is something that we need to focus on, which is what this white paper covers as well. So these are kind of the key takeaways that I have. Key sustainability indicators that are essential for net zero emissions. We talk about that in the white paper. We also talk about the technological enablers that are critical for sustainability native 6G, and then the importance of circular economy, observability, and choice for implementing the sustainability indicators. So what's next? So right now in 2024, we're working on 2 white papers. The first one is going to be a companion paper to the RAN KPI, sustainability KPI white paper, and we are working on identifying sustainability KPIs within data centers and core networks, because we're seeing core and data centers consuming more power. And the one that we just recently launched, we started internally discussing, is sustainable AI in telco. And this paper has driven a lot of interest within all of the Green Working Group members. And we have started to pull together, what does this paper cover? What aspects should we look into? And very early, what directions we have aligned on is looking at, not going broad, because then the topic of AI and its environmental impacts can be very broad. So we're looking at it very closely just in the context of telecommunications network. What sort of efficiencies can it enable? So really, really great work that's going on there. So I think this was my last slide. I think, yep. And I'm happy to take any questions. I know I went through a lot of material super fast.
Wonderful.
But hopefully that made sense.
Questions?
Great. I can ask, can I make a ask?
Yeah.
Is that okay? I think the ask would be, we always like to have guest speakers that come and talk to our members. So I know that, this is a focus within your organization. And if you have any guest speaker who would like to come and present, your perspectives on sustainability within 6G, we'd be more than happy to host them. So.
Perfect, thank you. And last but not least, we have Amir, who will speak to us about societal and economic needs, research priorities.
All right, I got 15 minutes, and I know I'm between you and the break, so I'll go as fast as I can. Let's see here. Today and yesterday, we kind of looked at all the different capabilities that the next generation of cellular technology would provide to us. And here is, I'm hoping that we can put it all together and say, what does that mean for society? My colleague Bhushan talked about the environmental impacts of sustainability, and I'm going to touch about economic as well as the social aspect of that. I'm the new chair of this working group, and I would like to basically first acknowledge my vice chairs that unfortunately couldn't be here, Joe Schumacher of AT&T, and as well as Jeremy Nasser of Verizon. Thank you. Of Verizon, as well as Maddie's here, driving us all, as well as Carol's here. So it's great that all of us are here and kind of like trying to determine how we can harness the new technology and figure out how we can kind of address some of the challenges that the society is kind of like feeling and experiencing. So 6G will be contributing significantly to the improvements of economic growth and increasing productivity, increasing the quality, time to the market, and so forth. And the question here is that how can we use 6G to address the digital divide? So these are the different pillars that we are looking at, and Bhushan talked about the North Star. You see here, there's a lot of different activities, and one can get really lost in terms of where should we focus on, because all of them are important. Should we pick quality of life, or the economic growth, or privacy and trust, or digital equity? From our perspective, we have digital equity as our North Star. Our view is that if we can address the digital equity, we can lead to economic prosperity. That would lead to quality of life and bring forward all the different aspects of privacy and trust that are important for society. And the R on the bottom, you'll see the different sustainability activities that are non-environmental, because my colleague Bhushan is taking care of that with his very capable team. And within that sustainability that are down here, our focus is going to be on hunger and eradicating hunger. One of the things that I would like to bring forward in this setting is kind of like just trying to paint the challenge that we have here in North America. And if you kind of take a step away from North America and even just say United States, right? United States is pretty big, you know, country. If you look at it, it's about 9.8, million square kilometer in terms of its area in terms of rural. 97% of the United States could be considered as rural. And we have about 19.5% of the country are living in the rural areas. That translates to close to about 70 million people. If we can kind of say, okay, what can we learn from everything else that is going around the world? I mean, South Korea would be a good example to look at. Right, we talked about all this different connectivity. We have digital equity as our North Star, right? And say, okay, fine. What happens if we address the digital equity by having all these different, connectivity challenges, to overcoming all these different connectivity challenges that we have? Well, we would be like South Korea, right? Or maybe like Japan, right? In terms of connectivity. But if you look at South Korea, my colleague, our colleagues and friends are here can correct me, and I'd love to have that discussion with you offline, is that South Korea, in spite of having all this great connectivity, has challenges in terms of digital equity. And how are they going to address that? I think is going to be important for us to learn from. And if you could kind of look a little bit further and say, okay, how is Japan is doing? That it's got also a lot of has overcome a lot of different connectivity issues. How have they addressed that? That they are maybe, in some people's opinion, one step ahead of South Korea. And I think it would be really good to kind of learn from those activities. And if I go to the next slide here, in terms of saying, okay, so what is our strategy? As I indicated, the strategy is really laser focused on digital equity. How can we use the technology to address that? And then, in addition to the technology, there are regulations, there are policies that it needs to be addressed. So how can we create that momentum? How can we be part of that ecosystem? And then how can we bring it back to the technology, right? Something that our good working groups, technology working group or spectrum working group, or the roadmap working group, can actually touch and feel and say, all right, this is an area where we can focus. Right? One aspect would be kind of like, how do we provide connectivity using, using fixed wireless access or combination of that with NTN. The other one is actually simplification of operations. Ease of operations, right, is a major challenge in the cellular technology. And we have, SKT here as well as the LG Plus here. They can attest to how easy or difficult it is for people who are not cellular savvy, like people in, let's say, education departments or healthcare or industrial automations, right? How would they adopt the 6G technology? So I think ease of operations, ease of deployment is really very important in terms of being not only spreading, that cellular capability across, regardless of if it's urban or suburban, more importantly, even in the rural. All right, so digital equity, right? Here's where we kind of like, maybe we can dive into the next level of steps and say, okay, so what are the challenges, let's say, in South Korea, despite all the connectivity? I mean, there were a couple of slides that will show is the entire, the country is kind of like red,
with all the different, cellular coverage that we have. If I'm not mistaken, about 1 million LTE stations and maybe about 300,000 5G, base stations are in South Korea. So connectivity is really shouldn't be a problem. But you see that there are other challenges in terms of access disparity. Different type of trains and environments, how you can have different levels of access in terms of technology literacy. How are they in terms of efficient in terms of using those technology? Affordability, I think that is really the key. You can have access to technology, but you can't afford it. How can that help you? I think that's also very important. Language and cultural challenges. I mean, most of the activities, most of the capabilities are in Korean language. And for people who may not be from Korea, it will be a challenge for them. And then finally would be the economic disparity. There are a lot of different programs that are instituted in Korea that actually address some of these challenges in terms of the government initiatives, private initiatives, and so forth. So to be able to address this. And in Japan, in specific, there are different programs in terms of the universal service obligations that they provide from the government, capabilities in the rural areas. So people have access to low-cost connectivity as well as the low-cost cell phones and so forth. So this one is big for us. And once you address, that digital equity challenge, then it becomes the economic growth. How do you use that capability, right, in order to improve the society, the economic activities, being like in the enterprises, different set of enterprises in terms of, starting, cultivating the different micro and macro economics that are required in order for these, rural environments to flourish. The challenge here is that if we don't have this economic growth, it will be almost like a handout, right? And governments can only do so much of a handout. So we need to kind of figure out, how do we make sure that machinery start working? How do we ensure that the technology is available, the technology gets put in the right use? And of course, with the support of legislations, regulations, private sectors, as well as the government to help that. Within the United States, I think a couple of people touched on that, and JD also indicated that there are many different programs that address these, and there is a $60 to $65 billion, depending on how you count it. There are funds available to address multitudes of challenges and issues that today are facing the rural environments in terms of their economic growth. In terms of the quality of life, so how do we improve the quality of life, right? Better education, better healthcare, right? Better accessibility to food or to shelter or to housing. All of those things would lead to better quality of life, starting from having that capability, accessibility, utilizing it, putting it into your economic growth that would lead to your quality of life. And the list can go, pretty long in terms of what that would mean in terms of the quality of life. But nevertheless, it's kind of like the implications of the economic growth. And then in terms of the data privacy, this will come simultaneously as the quality of life improves, and you can have those different capabilities or affordabilities, that data privacy will become an issue, right? And then not only the privacy aspect of it, the security of it, especially within the rural areas, there are a lot of elders, and deepfake can play a key role in terms of taking advantage of the people who do not have that level of sophistications in terms of technology, be it in terms of mimicking someone's voice or mimicking someone's video in terms of asking for money. So this will become very quickly a challenge for the environment. And then in terms of sustainability, sustainable society, and there are quite a few of them that I kind of talked about that are non-environmental sustainability, and we have selected eradicating hunger. And it sounds like a pretty ambitious goal, and how do we do that? And really today in the United States, let alone kind of like in North America, what's the hunger challenge? And if you kind of like scratch it a little bit, you'll be very surprised that 1 in every 8 households, but 12.5% of the households in the United States have challenges with hunger or lack of food or nutrition. 25% of American adults have food insecurity. 44 million people in the United States have food insecurity. 13 million children in the United States are food insecure. 49 million, in the United States turn to food programs, and 100% of counties in the United States have hunger or food problem, and there are 3,000 counties in the United States. So you can kind of like get just the scale of the challenge. So hunger, it is a problem. Food is a problem for the United States. So with that, I think that's my last slide. So my ask, taking a good lead from my colleague, Bhushan, I really appreciate if any one of you would like to come to our SEN working group and provide your perspective, especially what are the things have worked in your area or technologies you're embracing, and kind of like exchange the idea. Now, ready for questions.
Thanks, Amir. And I think we do have some questions.
So thank you for your presentation, and I just found have a very impressive. You can cover some wide range of aspects in the social side. And then when it comes to the data privacy, is usually my understanding is core cloud-based AI operation. For example, some AI application is based on some centralized server is always experiencing some privacy protection from some user information delivery from the user side to the some server side. So you still have some when the AI can improve the some and guarantee the some data privacy you are mentioning was shared screen. So I just want to clarify this the relationship between data privacy and the AI application. I'm not pretty sure about this. How we can provide this further enhance this data privacy from this AI application.
Excellent question. That was XR or AI?
AI.
AI. Very good. So let me just take a step back and just say, in terms of the privacy in general, is a major challenge, especially when you do any kind of offloading. If you are on that device, if you are on your own device, then you are more secure. But the minute you start offloading, if you look at a lot of different use cases, XR being one example, right? And AI and XR actually goes hand in hand together in terms of AI being used either in terms of determining the right frame rate or understanding what kind of bandwidth or capability the network has in order to make sure that the quality experience has been reached. So AI also plays a role in, let's say, in this one use case. So how would privacy come to the play? The minute you start offloading comes a challenge. And how do you ensure that you're offloading? Because once you offload, you already have your environment knowledge that you've gathered with your XR glasses, right? And you could be in a hospital, but you don't want people to know that you're in a hospital. You may be in a private setting. You may be in a corporate environment, but you don't want to, provide that information to anyone else. And that is available. So how do you address that? There are multiple different capabilities that are being looked at now in terms of either masking some of the environments, or actually providing bifurcation, which means that part of the data will go to one edge and the other part of the data will go to another edge in order to, and the way that are being also encrypted so that they can reverse engineering. It is very important, that aspect, because many of the countries that the CSPs are state-owned, right? Where the governments may have access to your information that you don't want them to have, that verification of data becomes very important.
You mean there's some data analytics perspective, and some sensitive user information can be filtered by the AI-based.
Yeah, so and then you can divide it. You can actually send a part of the information one edge, the other one on the other edge. Both would be encrypted, not being able to reverse engineering. There are multiple different capabilities that are being studied now.
Any other questions? Susan?
Yeah, I don't need that. I can speak loudly. Can you all hear me?
Yes.
Yeah.
This is more of a comment, Amir, than it is a question. So this is where the rubber really hits the road, right? Yes. When it comes to 6G. And I think that the industry, certainly here in North America, but globally, is really going to need to think about how to articulate this value in a way that translates to the marketplace, so that 6G is truly distinctive. 6G becomes something that consumers really want to use, that companies really want to provide, because we didn't quite have that with 5G. So I think this is a really compelling place for the industry to spend some time on this topic of societal and economic benefits, because this translates the fun part that you are all having with the engineering, the technologies, et cetera, figuring it out. But that figuring it out isn't ultimately going to sell 6G.
No, absolutely, and you're absolutely correct. And what I was trying to portray also is that we don't need to figure it out all on our own. Someone else has already done some parts of it, right, that we can learn from, the pros and cons, and kind of maybe also being able to do a shortcut, so we don't need to go through all those pitfalls. That's why I was choosing South Korea as an example, Japan as an example. You could argue that our smaller countries compared to North America, but the challenges are all the same despite having those connectivities, right? So the first step to address connectivity, the second is the other capabilities that needs to be cultivated in the society.
Any other questions or comments?
I think that this 1.5 day of this the workshop looks like very much proper to share the ideas and know-hows between two parties.
It's working.
Working? Okay. And then looks like this room is full of the wisdom and the knowledges. And the 6G Forum has developed the three collaboration policies. The first one is the invitation of the NGA to the annual international event of the Mobile Korea. So this event always, we are holding this event always during the week, which includes the November 1st. So this year, November 1st is a Friday. So this event starts from the October 28th until the end of the week. Actually, this Mobile Korea consists of the three events. 6G Global, 5G Vertical Summit, and then the regional workshop. Regional workshop is for the developing countries. And this year, 6G Global is not from the Tuesday, from the Monday to the Wednesday, 3 days. 5G Vertical Summit, 1.5 day, regional workshop, a half day. And then we made the MOU between the NGA and the 6G Forum. But at that time, we made 2 years of we defined the 2 years of expiration date. Unfortunately, this expired till the last November. So our opening ceremony of this Mobile Korea is hosted by the MSIT and organized by the 6G Forum, right? So the executive member of from the NGA is attending the Mobile Korea, we like to renew the MOU. So that will be performed during the event of the opening ceremony. So usually that opening ceremony is hosted by our minister. So that's our first bullet for the collaboration. Then in that case, maybe that expert may give the keynote before the opening ceremony. And that's pretty much usual. Second, the collaboration, the bullet is today. This one is the sort of the kickoff workshop between the NGA and then the 6G Forum. Why don't we have make the next chance again? Second joint workshop between two parties in Korea next time. So as you see, we have the very good opportune chance because during the March week of during March 10th, there will be a 3GPP workshop and the whole three TSC meetings at Korea. The venue location will be maybe Incheon, the airport city. And then I believe maybe if we hold the joint workshop, maybe the period is maybe the after the workshop will be better than the before the workshop, right? That's the 3GPP meeting. So then we have discussed about the possibility and location of our second joint workshop last night. So looks like everybody Jeju Island, they like the Jeju Island, but we'll see that the possibilities anyway. So first of all, we need to agree about the peer dates, right? Area. Third one is to make the collaboration between two parties more concrete. So I like to propose, why don't you develop the kind of a joint white paper? Right? So because it will be the first real collaboration, practical collaboration. So let's don't make too much ambitious. Okay? So maybe 1 or 2 volume of the white papers will be maybe good, very good enough as a starting point. Yeah. So as we know already, the active members of both parties, all from the telcos and vendors, solution providers, and then the SMEs, global companies. So it will be the white paper will be really nice for both parties, and also for the other experts. Yeah.
So once we write the white paper, will it be submitted at the ministerial level, like we did with our white paper on the used? Any
Yeah, so Amitava is referring to the white paper that joint white paper that we did with 6GIA, and the US and EU governments were working together in what was called the US-EU Transatlantic Trade Council, or TTC. And they came to both of our groups and asked us to prepare a roadmap for US and EU on 6G research. And so we worked together and produced that paper, delivered it to to the TTC, and they presented it to the government, officials. So
basically, the NGA is also the kind of the public-private partnership organization, same to the 6G phone. So yeah, that should be the pretty much usual way of the. Yeah. And then we have time to discuss the not only for those three policies, but for the other issues also. So when we discuss about the collaboration issues, let's discuss including those three policies. Okay. Thanks a lot.
perfect, thank you. So I'll open it up to everyone to talk about these or other aspects of what we did over the last day and a half. If there are particular topics that you think are especially relevant or important for us to focus on together, that could be something that could turn into a joint white paper, or it could be a topic for a virtual workshop that we could hold, to dig into that. So would anybody like to share thoughts? Just put your hand up and I'll bring you the mic. Here you go.
Yeah, so thank you. I think this 2-day workshop or 1.5-day workshop was really enlightening and a lot of good presentation, but we should focus on 3 areas where we can cooperate, right? And there should be common areas where we have mutual interest for the immediate future, right? And that is up for discussion. So I don't know if you want to focus on mid-band research with a certain application, which we should focus on. Like, can we focus that UAM was really interesting, and the applications of 7 to 15 gigahertz on UAM technology. So the main message is we should have some concrete area of focus where we should cooperate, and it is up for discussion which are the areas we should focus on. Thanks.
Thanks, Amataba. Are there thoughts on which areas are there particular use cases associated with the expanded midband, or are there other technology areas or aspects? Doug, I think I saw your hand go up.
So yeah, I'll just echo that. I think focusing is a really, focus on something that's somewhat narrow so that we can actually create impact without going, without being too thin. I think that makes a lot of sense. So I agree with that, is trying to just select things. Just thinking back from the past 2 days, which has been great. I think all the presentations helped bring some ideas, and the ones that jumped to my mind is the urban air taxi or urban mobility. I don't know which is the right term for that. That was very interesting, and I think there's a lot of challenges there. Fixed wireless access, I heard today, was something that we know in North America is something that came out of our discussions and our operators telling us it's one of the most valuable and valuable use cases and technologies in North America, and we need to make sure that that gets some priority going forward for 6G. So I think that's a good one to focus on. And then what I represented on, I think, is still on the 6G resilience and reliability and some of those other technologies. There's a good opportunity there to just jointly go back to the group in Europe has this a lot, that's forming this group and saying, hey, we're interested in joining too, and just be part of that discussion together. I don't know if that has to be one-on-one, but if we can just we can go back to them and ask to be part of it, and just say that we talked about it here today.
Interesting thoughts.
Yeah, thank you, Doug. Any thoughts on those? The UAM one, I think, is very interesting to me because of all of the challenges associated with it. And it's something that I'm not aware of a similar project in the US. And so it would be interesting to see, for us to do a little research on what is going on in the US with respect to that, and then look for areas where perhaps we could learn from you, or share ideas, or share sort of our unique challenges in that regard as well. Yeah.
So yeah, it's a great idea. And also, why don't we extend our reach to other application areas like autonomous robotics or something like that? I think you are quite aware of those areas as well. So it would be great addition to that.
Yeah, I'm a top here.
Yeah, so for the UAM, so there is a program. So there are 3 PAWR programs from NSF, right? So one of them is called AirPOM, which looks at drones, but they can migrate to air taxis. And as I said, there are a lot of companies like Hughes Network who are interested in these air taxis or UAMs. So AirPOM, and you can talk to NSF and these programs, PAWR programs, that they do AirPOM. And MITRE was doing it from the OpenGen program, which has now stopped. Thanks.
Thanks, Amitama. Yeah, and that's a great suggestion to look at some of the other verticals. I really think we need to learn the lessons from 5G, and we all had great expectations for adoption by the verticals of 5G, and we're now looking at 6G and looking at the same verticals and the 6G use cases for them. But what's going to be different this time? What's going to change? Why haven't they adopted? And are there lessons to be learned? And I think, Korea, of course, was one of the first. It was the first to deploy 5G, and there were great expectations that these new use cases would emerge and thrive there, and the U.S. carriers who moved quickly into 5G as well had those expectations, and so now let's not repeat the same mistakes as we go into 6G. It's great to make all those capabilities available, but if they don't adopt them, we're not accomplishing anything. Other ideas or thoughts?
Let's have some opinion from our 6G forum, 6G technology committee chair, Dr. Bo.
Thank you.
I don't have a special officer that I have in mind, but UAM is certainly a very good subject, since the Korean side, 6G forum, has members, a lot of members dedicated to UAM. So maybe that's I think maybe first topic we can talk about. And I think the fixed wireless access, I think was mentioned. Maybe that can be the second priority. And but in general, we can maybe add some wireless access aspects for joint white paper, for example, or MIMO, or advanced duplex, those technologies that could be additional candidates.
Good, thank you. Other?
And from 1.5 days workshop, we have some so frequently mention about the CBRS and the private 5G. So such some local network solution, and so we are really willingly have some looking to some future-proof business and some technology improvement for the 2030 era. So it will be a kind of a local network approach in the US and Korea is one of the key factors to be shared.
And thank you. And when you say local network, is that the same as private network, private 5G, private 6?
Yeah, but also including the CBRS, the
shared spectrum.
Yeah.
Got it. Yeah, and I guess unlicensed in the US would fall into that shared as well. So yeah, I think that's a great suggestion. Other thoughts, ideas? These are all really good, and I think that thank you very much for these suggestions and invitations. I think that provides great opportunities for us. I think we can identify some of the specifics of the areas that we want to work on. In terms of participating, it's not my decision to say that we're going to do this. It's a decision for the NGA and the steering group, and so I will take this back to them, and we will be sharing the results of this past 2 days with our leadership team. We have most of the working group chairs here presenting, but the rest of the leaders from those working groups will share the experience with them as well, and then bring this back to the steering group for guidance on how to proceed with the next steps. But these are all really very good suggestions, and I appreciate you bringing them to us. Thank you. Is there anything else that anybody would like to add?
What this joint, anything to do with this, how to do proof of concept? So that's the how to join proof of concept. Any idea on the logistics and how that could be possible?
That will be also nice. Yeah. That will be also nice topic. Okay.
Yeah, so I saw that the demonstrations and proof of concepts is part of the plan. So I guess the question is there a way to collaborate on some proof of concept or technology demonstration?
The proof of concept, the jointly do that is not, I think that's not easy job.
No,
right?
it's not.
The
distance.
But at least we can show our strategies, and then from that we can refer both parties the strategies.
Oh, that would be so. We can try to avoid duplicating where necessary, and maybe collaborate by focusing on different areas where we can each bring. Thank you. Would you like to make any closing remarks, or?
If you're tired.
No, I'm not tired. I just.
You're the host.
Well, again, thank you all for traveling here to be with us, for the work preparing your presentations, for the valuable information that you all shared with us, and for the interaction and discussion, the questions on our presentations, and the feedback that we will be incredibly valuable to us. I see this as a really important step forward for our organizations. We do have to go back and revisit that MOU and make sure we get that updated. So thank you all. Safe travels, and enjoy the rest of your time in the US.
Thank you.